Milton. I am your host today on the .NET community team, and I'm joined with my colleague, Myra.
Yeah, so I'm joining from Southern California, and I'm also a program manager on the .NET team. And I'm responsible for the .NET website, so we'll show that in a little bit.
Oh, excellent. So we're talking about C# today. Can you elaborate a little bit? What's the breakdown? What are we covering?
Yeah, so we're gonna go today through the fundamentals of C#. What is C#? And some of like data types and structures that you're gonna be using. So it's gonna be beginner-friendly content. And we're gonna go through some interactive lessons for you to play along with us.
Oh, that sounds great. Why don't we go ahead and get started?
Sure. Okay, so for those that don't know, like, what is C#, right? And so C# this is our tagline. It's a modern, innovative, open source, cross-platform programming language. And so instead of showing you the slide, what I'm gonna do is I'm gonna jump into our new C# page that we just launched on the .NET website. So if you go to .NET.Microsoft.com, we have our new page, and I think like soon we're gonna have C#.dev redirecting to this page. I don't think it's working yet. But then it has all the resources for you to get started with C#. And so C# was launched like back in 2002. It was originally like a Windows only for you. So it was built, launched with .NET 2002, Visual Studio .NET 2002. And it was created to build Windows applications in the .NET framework. So C# runs on top of another platform called .NET. But over the years, the language has been evolving. It added new functionality, new features that make the language more modern, and you can see, you can play along with some of those features right on the side here. So you can see our basic like hello world, which we'll go over in a second as well, and some features like string interpolation, link, and so forth. Go ahead.
I was going to say, and that's right in the browser on the website, correct?
Correct. Yeah, you can click run code and it will load it's going to compile, and we're going to go through some of these concepts in a second. And then we have some awesome developer tools for you to use with C#. So Visual Studio Code and Visual Studio are some of the most popular tools for you to code in C#. And then we are now on C#9, or the version of the language is C#9, and we're launching C#10 in November along with .NET 6. And C# is one of the top 5 languages used by projects on GitHub, so it's super popular language, and it's like on one of the most loved languages on Stack Overflow developer survey. So there's a lot of love and a lot of community resources for you to get support, to get started. The other interesting thing with C# is that you can build anything with C#. So you can do desktop apps, web apps, cloud, mobile, games, IoT, AI. So it's a vast number of types of applications that you can build with C#. And then we have, if you go to the lessons here, and there's also a shortcut like .NET/videos, you have a bunch of lessons that you can learn more about if you were doing web application or if you're doing desktop apps, data. There is ton mobile. You can find all kinds of videos for you to learn and deepen your knowledge beyond what we're going to cover here today, because we're going to go through the fundamentals. So if you're going to want to dive deep, you can go here. All right. So C# is also object oriented, and we're going to touch a little bit on this. So it's kind of like it comes from like the C style of languages, so similar to like C and Java, the style of the language. And then we covered that like one of the most loved languages and one of the top languages used in GitHub. All right. So what is a programming language, Jamie? So a programming language is like enables you to write instructions for the computer to carry out. It's like you're giving like a recipe, like a step-by-step instruction of what you want to do. And each language has its own syntax. So if you learn I don't know, Python or Go or other like programming language, they're going to have their own particularities of how you do things. But once you get the concepts of programming language, you can switch from one language to the other as well. So a lot of things that we're going to cover in terms of data types and things like that will probably be applicable to other languages. But we're going to go over the C# syntax. And the instructions that you write in a language, it's called source code or just code. You can say, oh, my code is not working or something like that. The other thing I wanted to cover here is some very basic concepts that we're going to need from object-oriented programming, which is the definition of like a class and an object, which you'll hear all the time when we're talking about programming in C#. So a class, you can imagine, it's like a blueprint of a house. So you're defining what that should look like. And then the object is that we say that it's an instance of that class. So when you create an instance of that class, you create an object. And so here you have the blueprint, which is the class, and the actual house is the object. And you can think of that, you can define like classes for like persons or dog. I have an example here of a dog or a car or whatever is the business requirement and the definitions that you need to work on, like either it's a customer or a product, you're going to be working with classes in C#. And so in the other two things that I wanted to get across that it's also going to be useful when you're doing C# programming is the concept of properties and methods. So properties are the attributes of an object. So if you think of a dog, you can think of a breed or size or weight. This is defining some of the attributes of that object. And then methods are like behaviors or actions that that object can do. So a dog can sit and bark and fetch and run. So this is kind of the distinguish between properties and methods. So I think we can go ahead and get started with our lesson. And we're gonna jump into learn. And so do we have a link handy for people that want to follow along?
Yes. Everybody who would like to follow along with the module, we do encourage you to do so that we can help you live. You can find all of the resources. Thank you. This is thank you. The resources link, aka.ms/C#_resources, will take you to all of the resources for this event, including this Learn module that we'll walk through. There's also tons of other resources in that link as well that will help you during this event and afterwards. We're also doing a Learn challenge, which is very exciting. If you complete the Learn module, we're actually doing prizes where you could win some really awesome .NET swag. So head on over to that link and check out the Learn Challenge. Also head on over to that link to get the Learn module started.
Yeah, so just to give a quick intro of what's Microsoft Learn, right? And you're gonna find tons of resources for you to learn, not just about .NET, but about Azure and about other Microsoft technologies there. Today we're gonna be doing the Learn C Sharp, the first item in the collection. So you have hours here that you can dedicate hours of learning. It's gonna be interactive. So you run, like I think most of the lessons here, they are gonna be on the browser across Microsoft Learn. And in some cases, you're gonna be working on your own environment. So it depends on the lesson, but our lesson today will be all in the browser. We're gonna be doing, we're not gonna be installing anything, but once you take your programming in C# to the next level, then you're gonna want to download some of the tools, and I can show you what it looks like in Visual Studio Code, and you're gonna need a special program, which is the .NET SDK, to when you want to use it in your own computer. But today the lesson will be all online. We're gonna just be going through some of the fundamentals of the language, and our modules are all in the browser, so you can learn right here.
Perfect. Let's get started.
So in this learning path, you see a series of lessons. And once you complete each lesson, you get points and unlock achievements. So it's part of like of what Learn can do for you. And then you can, once you go to your profile, you can see like what are some of the lessons you took, and then you're gonna increase your level points here as you go along. So we are gonna write our first C# code. I'm gonna start from the beginning. I'm gonna skip some. You'll see that I'll be skipping in some cases some of the things so that we can cover more content today. Otherwise, like it's a lot. Like it's just the first one is like 4 hours of content.
Yeah, we want to get to the meat of this all. There's tons of extra resources in the Learn modules that provide extra content and context, but we're really going to cover the basics here.
Yeah, so you'll see when you launch the module, it will have the content in the left side and then the .NET editor in this side. And then you'll see this green run button here. And so in here, you can test the code that you're working on. So let's try to copy and paste here. And this is going to be our first line of code in C#. And we're going to go through and dissect what that means. Okay, so we did hello world. One thing that, yay. And one thing we wanted to cover, Jamie, is that we have a TikTok, because when you're learning a programming language, we see that all programming languages have a hello world app. So I want to get into a little bit of the history of that.
Sure. Would you like me to share that?
Yeah.
Okay, great. Ooh. Load, please. Okay, let's see.
I'm going to remove mine for now.
Is it working?
No, I think it has no audio. Did you share the audio?
Okay, can you see the TikTok video?
Yeah, we can see. I don't know if we can hear. Okay. Did you share the audio? When you share it, there is like a checkbox.
Let me do that. Oh, it's...
Otherwise, let me try from here. So I'm going to stop screen and I'm going to share again. Okay,
can you hear that?
Let's see. And let me know if you can hear. Let's see.
also just pasting the link to the TikTok video for anyone
Yeah,
who would
yeah,
like to
yeah.
watch
Otherwise,
it.
yeah, go check. Like we can follow. We can follow later. Let's see.
We've
But
been
it's
having
pretty
some
cool.
issues all morning. Okay, I can see it on your screen. Can you play for volume?
Let's see if it's playing or not.
Hello World. Where did that come from, Hello World? Who was the first person to write Hello World, and why are we all still doing it? Well, his name is Brian Kernighan, and he wrote it 49 years ago in 1972. But why did he pick Hello World? Why not literally any other phrase? I don't know. Let's ask him.
My memory, which is now probably completely meaningless because it's been so long, is that somewhere in my life I had seen a cartoon that showed a chick just coming out of an egg and, cracking, little head poking out, and a caption that said, "Hello World." And for some reason, it stuck with me. And so somewhere I wrote a program that did that. And the rest is history. I have no idea why it's been picked up. I don't know whether it will last forever. There are web pages with Hello Worlds in hundreds of languages, if not more. So maybe it's useful in some sense.
Hello World.
So that's it. Like we've been using that. I love that story. I think like it's so endearing to see how like something that it was not meant to be like the
Defining feature for
and so you have it there. So now you know.
Yeah, I had no idea it was 1972. Wow, I had actually no idea it was that old. Surprising.
Yeah, and so let's dissect here. And what I want to do also is it's like I'm like it recommends you to kind of type it in, but because of time, I'm gonna like copy and paste. But as you learn, you wanna like
physically type it
so you can like use that muscle memory, and the more you learn, you're gonna like fix those learnings in your head better instead of copying pasting everywhere. Because like if you go to Docs or you go to Stack Overflow and then you just simply copy and paste code without understanding what it's really doing, like you're not really learning, right? So a couple of things about C#. One, it's like it's case sensitive. So here we have what we talked before, a class and a method. So we have a class called console that we can work with that class for output. So it's like you use it for console application. So it's application that you use on your terminal or your command prompt, they will run on those environments. And writeline is our method. And so notice that is like you have capital C here, capital W, capital L, like you have to write that way. And so if you make a mistake, let's say you put it lowercase, you're gonna see that it's gonna tell you, you're gonna get some red squiggles. And if you try to run this, it's gonna give you a message. So you're gonna start to learn how to interpret those messages. So when you get an error message, it will tell you where it happened. So here's the row and the column. And the column is like each position on the line. So if I add a space here and run again, it should move the column, the number on the column. And then you get an error message telling you what happened. So it has a code and a text so that you can like search for it if it's like a more tricky one. So for this one, we can go back and fix it, and it's easy. And then now it should run again. Okay, the other thing, yeah, yay. The other thing is that here we're passing an argument to this method, which is a string literal. In strings in C#, you use double quotes. So, and in some language like JavaScript, like they are interchangeable, like the single quotes and double quotes, but here they represent different things. So in C#, double quotes is a string, And then character is a single quote. So if you do this and try to run it, it's expecting one character. So it's going to give you an error saying too many characters. So when it's like that, it's one. It needs to represent one character. So again, you can go ahead and fix your code and it's all good again. If I can type. All right, let's keep going.
Sure. I have a quick question, Myra. Why do we write console at the beginning? What is a console?
So the console is a class. Is a class in C# that represents this output. So you can do color. You can do like and you have like methods, like the actions that you can do with that console. So like here we're saying write a line. So it writes the text that you pass and also does a line feed after. We also have another one, which is write, just simply write. You're like, for now, you're not gonna see much difference, but we're gonna see later on the lesson that you can control whether you want the line feed or not and formatting that output a little bit better.
I see.
Yeah. And so let's copy this one. So now we're going to go into comments. So while a single line comment in C#, it's like double, like a 2 forward slashes. And so comments can be useful to either do the like if you're not ready, like you're testing some things and you just want to comment it out or test if something's like creating a bug in your code, or if like you want to add explanations of what your code is doing. So let's run this. So here we commented out the hello world, and now we have 3 lines of console.write. So we have like, congratulations, you wrote your first lines of code. So here you can see that you wrote all in the same line. So if you add like write line here, for example, you have you're gonna see the line feed happening. So now you change the formatting based on that.
So to clarify, write line makes the comment on its own line, and everything on write line makes it on the same.
So write makes it on the same, and write line it adds it's like if you're typing on a word and then you hit enter or the return character, then it's like the line feed, right? And so let's go into how it works. So we already covered what is a programming language. So what is a compiler? We're going to be talking about compilers here. And so a compiler is a program that will convert what you wrote, your source code, to a format that the computer can understand and execute. It will it will create an executable. The name of the C# compiler is called Roslyn, and Roslyn will have other functionality, like it will provide other functionalities beyond the compiler. And so we say that C# is a compiled language versus interpret. So in the case of C#, so you have to write your code and then compile, and then you can run it. There are the interpret language like Python or JavaScript. They will run line by line, but you don't need to compile and produce an executable. And so the compiler will analyze your code, and then, as you saw, if there's something wrong, it will produce a list of errors. And so C# syntax. So what is syntax? We've been talking about syntax as well. And so it includes the keywords, the operators, and other grammar rules that the compiler will enforce when trying to build your program. And then syntax highlighting is also part of that. And you saw on the browser editor some red squiggles when we had errors. It will also highlight different things on your code in different colors. So it's going to highlight like keywords in like here is a Visual Studio screenshot. So it's gonna highlight keywords in blue in this case, and then classes, methods, and then string literals. It's gonna have different colors. So when you see the whole code, it's gonna be easier to read versus like a notepad or some text editor that would be all black. So the source file will be like a text file, so you can open it anywhere, but the code editors will help you to be like easier for you to program and have all additional tools. Then to access properties and methods of a class, you use the dot, the period. So to access anything, you do dot, and so you can access the methods and properties. Each statement, which is like each instruction, needs to end with a semicolon. So here it's complaining about like we use lowercase, so it's case sensitive, so it's wrong. But I also missed the semicolon at the end here. And we use parentheses to pass arguments to call a method. So if the method doesn't have any arguments, it's going to be empty. And if you have multiple arguments, you can separate them by comma. And then double quotation marks will be the literal string versus the single quotation for chars. Okay, and here is the same program that I had, but in Visual Studio Code. And I saw someone asking before, and let me see if I have it open. I have. So here I created a basic C# Hello World using .NET, the CLI command. So this is the template that you get for a new console app. So this is, so they were asking, do you need the main method on a console app? And I thought it was an interesting question because you used to need it until C#9. So on the current version of C#, you can actually delete all this and just have that, and then it's gonna work. So it makes the structure of a basic C# app so much cleaner. But you can see here like some things that play on the real code editor. Like, so here is Visual Studio Code. Like we have IntelliSense, we have the highlights, and it's gonna be much easier for you to understand the code. So, and I love this theme. It's called Dracula, if anyone likes the colorful one. All right, so we cover all this. And here, so in this case, I'm not using the using statements because this is a special editor, so it's encapsulating some of those concepts. So we're focusing here on what would be inside the main method, or like just the key methods. But you wouldn't need, like if you have a full program, you would at least need the using statements. Okay. So I think we cover all that. I don't want to spend too much time on going through the text. You can do it on your own, like take your time to like read everything. The other thing that is important to understand is the flow of execution. So as you could see, like they are executed in order, one line at a time, until the instructions are over. There are some instructions that can change the flow of execution. So as we learn more about how to program in C#, you can learn about those things. All right, so I think we're getting to our challenge. Okay, we're gonna do our first challenge. Jamie, are you ready?
I am so ready.
Okay, so
I hope everybody else is ready. We're all ready? Okay.
All right, and so we want to produce this output. We want to do, this is the first line, this is the second line. So how can you do that?
for all those following along, please feel free to do it. I would write console.writeLine. I can't, this thing, what is it called? Yes, those. Okay, it automatically did it. And then I would do.
Yeah, I'm reading your mind.
Perfect. So you know what I'm going for. And then I would do quote. This is the first line.
What kind of quotes? Double.
Double quotes.
All right.
Air quotes. Yeah, with the semicolon, and then console.writeLine. The same aesthetic.
All right. And then, okay.
Yeah, and then this is the second line in between the quotes.
Yeah. Yeah, and so all of these lessons will have some challenges for you to try on your own and see if you guess it right. But then it shows the solution. You got it!
I did it! Congratulations, everybody online who did it as well. It's very exciting. Okay.
All right. So let's see. What's happening?
And anybody who's doing this online, following along, the way Learn modules work is you can always go back and forth. You can go back to any portion of the lesson and review and redo everything, and you can go forward. So if we feel like we're going a little too fast, please feel free to say something, but also you can go back in your own time. Yes. Oh, there's another alternative to a solution as well, which makes sense.
Yeah, and so I think that's the beauty of programming, right? Is that there is not one single solution for the same problem. I think like your solution was cleaner, right? Like, and more concise. So I like the proposed solution that you have. But as you can see, like there's no like right or wrong answer in terms of how you did it. I think like as long as you get the right result, I think as you learn to program, what you're gonna want to think, it's like, is it performant? So sometimes the way you write can make the program slower to run and things like that. So that's kind of what you wanna think about. All right, so our first knowledge check. So let's see what we learned.
Ooh, what did we learn?
Oh gosh. All right. So what is the primary job of the compiler? So is it locate spelling mistakes, to reformat your code, execute your code, or convert your code into an executable format that the computer can understand?
See if you can get it before me, anybody online. But I'm going to go with D. The compiler primarily converts your code into an executable form that the computer can understand. All
right. And which of the following statements is true about C#? Is C# case insensitive? That console is a method and WriteLine is a class? You use double quotation marks to create a literal string, or if you make a mistake when writing code, you have to delete it and start all over.
Well, I really hope it's not the last one. So based on my hopes, I'm going to go with C, use double quotation marks to create a literal string.
Okay. And last question, what is wrong with this line of code? So you have console.writeLine. What is wrong with me? L should be lowercase, you're missing a semicolon at the end. The string should use single quotes, or it should be a comma instead of a dot between console and WriteLine.
Comma should be a dot between. There should be a semicolon at the end.
Let's check if you're right. Yay! Congratulations.
Yay! I learned. I hope you all learned.
All right. We finished our first lesson.
Congratulations.
So very basic.
Yeah. Do you want to take a moment to take some questions, answer any questions online?
Yeah, I was trying to answer some of the main, like I saw some of the like the main.
Sure.
Yeah, some people are
So
saying, oh, go ahead.
yeah, I was just I'll read them to you. How about that?
Okay.
So Ken from Pubble is asking, what extension is used when naming a file that contains C# code?
Oh, that's a good question. Yeah, so let me go back to our Visual Studio Code. So so it's .cs, the C# files.
Is .cs.
Mm-hmm.
Okay. Oh yeah, I see that at the end.
Yeah.
Madith from Twitch asks, so WriteLine writes one line and write puts multiple things into one line?
So WriteLine, it writes what you have there and then does a line feed. So it enters one line. So, well, you always have like an enter at the end when you do WriteLine. So in write will always just concatenate and keep writing on the same line. Does that make it clear? I hope so.
I believe so.
Okay.
Feel free to mark in the questions if you have further questions about that. And Jorge from YouTube actually asks, can you explain a little bit more about the console, why people use it, and why it's so important?
So the console class, you're gonna be using that whenever you're gonna be writing things to like on to output on this. So like here I have it. Let me open like in Visual Studio. So let's run this. I'm gonna open the terminal and I'm gonna run this program that I wrote. And so let's see what else you have it here available for console as well. So when you do console dot, so now you can see like all the methods and different properties that you have for that class. So this will be useful for you for like if you're writing like scripts or quick things that are not gonna require like a fancy UI. You're gonna be using the console class. And so let's try to run this. So I'm using here what's called the .NET CLI. So you have like you can run through like the editor has like run buttons and debugging. But here I'm using the commands that are part of the .NET SDK. And so hopefully like it's a little bit slow in my machine. So hopefully it will run. So you can see like I saw more comments about the top level statements. So top level statements is this format of program that doesn't require the main. So it's all kind of implicit. It's like doing behind the scenes, but you can see that we have the same output here with just using and the console. So like we remove all that clunkiness from a basic program to have this, but it is the same. Let me go back to what we had before. It is the same as this, but you see how much easier and cleaner it is for someone getting started to have that.
I see.
Should we continue?
Yeah, I just have a couple more questions,
Sure.
and then we'll move on.
Okay.
Darren Evan asks from Learn TV, is it convention to capitalize C# source name file names? I'm gonna say yes.
Yeah. Usually, like you're gonna use, is it Pascal? It's like the cap, like each word will be the first letter will be capitalized. So I think it's Pascal casing, that we call it.
Pascal.
Yeah, I think it is.
We can clarify.
Versus camel case. So like, which is, so each, there is a, let me see if I can find it. There is some good resources for guidelines. So I think it's called Framework Design Guidelines. Let me search for it. And it's gonna, like, they have a new edition of the book, but we have a couple of the guidelines
In our
published
documentation.
on the documentation. And so it will cover like how you should name properties and methods. So you're gonna have like, because naming is hard, like, and so it's gonna have the conventions of how you like capitalization. And so how you should use like the capitalization. Yeah, so it is Pascal casing. So
Yeah,
so,
Pascal. Camel.
yeah. So Pascal case is like when you uppercase the first letter of each word. So usually that's how you name the C# files as well.
Okay, so that's actually a really good resource to have.
Yes.
for
like
naming
it has.
conventions.
Yeah, it has all like how namespaces should be, like what casing, like we typically would recommend for someone programming. So you can see that a lot of them are like Pascal, and then parameters, usually like a camel case, and then how you do like compound. So like it's a really good content out there for like conventions, like what are the guidelines that, and this is used by the .NET team to write our own code as well.
Oh, okay. Yeah, it makes sense that we use our own tools. Okay, last question, and then we'll get started with the second portion of our workshop. Is what is the best editor to use for executing C# files?
Okay. I would say like when you're executing, like you already have the program, so you don't really, I would say that for writing code, so you have the more robust Visual Studio editor. So that's so let me show you here. So Visual Studio, there is a community edition that you can download. It's free. So you can dip your toes into it. It's going to have a richer UI. You can create new projects. It's going to have some like debugging tools, profiling. Like if you really need to dip into like what's going on, it's going to have some connections like with GitHub and Azure, which Visual Studio also has a lot of that. So I think like both are perfectly good options. And then there are some other third-party tools as well. But I recommend Visual Studio or Visual Studio Code for you to get started.
Yeah, Visual Studio Code is really quick.
Yeah. And it's cross-platform as well. So like Visual Studio, we have an edition for Windows and Mac. And then for Visual Studio Code, and you can write your code in Mac, Windows, and Linux, because as we said before, C# is cross-platform, so you can write your code in any of these platforms using C#. And then, but you can also write code for mobile, so you can run C# on iOS or Android. So, but you write the code on one of these three, like Mac, Windows, or Linux.
Sure. Okay, let's go ahead and move on. We're going to be moving on to the next portion of the workshops. For those following along, we're going to be staying in the same module, just continuing on to the different
we're in a new lesson. Yeah.
Yeah.
And so now we're going to start looking at literal values and data and variables. So how do you declare variables?
Great. So for those following along, all of these resources can be found at aka.ms/C#, CSHARP_resources, for the links to this Learn module, as well as all the documentation that we're referring to.
Okay.
Thank you.
So let me go back to my presentation.
Sure. Ooh, one more pitch. And don't forget about the Learn Challenge that we're doing. We're doing the Learn Challenge. You complete the modules, and you can there's a chance to win some swag for the .NET Foundation store, thanks to the .NET Foundation. So make sure to go ahead and check out the Learn Challenge when you get a chance.
So,
Okay, now you can.
no, it's okay. Those are great. So we've been talking about like literal strings. So what are literal values in C#? So these are like hard-coded values that never changes. So it's fixed. Once you have that value, it's gonna remain the same throughout the entire program. So some of the literal types include like strings. So we talked about strings, char, integer, decimal, and Boolean. And so let's take a look at what they look like and what they're used for. So strings and chars are for representation of display of information. So text. When you're working with text, you're going to be working with strings and characters. So here we have an error, like as we said before. You need to do the double quotation. So let's do here the B. So we have one character there, and it should run fine. Yeah. The other one is integer. So when you want to work with like no fractions, so you probably saw in math integers. So these are the numbers, the integral numbers. So when you're working with numbers and you're using a right line, you don't need anything for identifying a number. There's no quotations, it's just the number itself. So you're gonna be using that for like math operations. The other one that you're gonna be using is like floating point numbers. So one kind of floating point number is a decimal. So decimal, it's you have the point. So after the point, you add a letter M to identify a decimal. If you do without the M, it's going to be a double, which is a different kind of integer. So decimal can hold a longer number. It's more bytes into it. And then Booleans is it's going to be very useful for you to work with like logic, right? So if you're trying to determine if something's true or false, the notion of Booleans are going to come into play. So also those are some C# keywords, true and false, like lowercase, all lowercase. Okay, we talk about presentation. And so here, let's run this just to recap. So here we have a string. So the compiler is building your program and trying to, like, it's gonna determine what data type you have. So here you have a string. Here you have an integer. And notice how the Boolean and the actual string here also print differently. So you have, this is a string, so it's not like it's just text. And this is the actual Boolean number. Okay, let's continue. So now variables, like how do we declare variables in C#? Let's see if I have any content here. Okay, so for variables, you're gonna store temporary values that you use in your program. So the variable will hold that value and store it in the computer's memory. So before you can use a variable, you first have to declare it. So to declare, you're gonna think about the data type that you want the kind of data to store, and then give it a name. So, and we're gonna give it some of the rules for naming a variable in this case. And you can read from a variable and write to a variable, so you can assign new values to it. And so look at how many rules you have just for variable names. So it contains like alphanumeric characters and underscore, so no special characters. It begins with a letter or underscore. It cannot be a C# keyword, so string or true, false, like any of the C# reserved keywords cannot be used for naming. It's case sensitive, so if you have used different in a sense like casing for it, it's gonna be two different things. It uses camel case, so like as we were talking before, between Pascal and camel. So variables you start with with lowercase letters, and then you append names to make it meaningful. So because you want to make that code readable to for someone, even your future self will thank you if you give good names in your code. And then don't include data type. So you'll see maybe some old code, even our samples might have, where you should be a practice to include the data type on it. And so that would be like if it's a string and then you add str into the name, we don't recommend doing that. Okay, we covered the theory so that we can skip. And so to declare, you do data type and a name. So here you're declaring a variable. And here you can see other data types, some of the data types that we just saw, char and decimal, and how following the rules that we just went over, how you would name them. Now let's set and get values. So let's do some exercises with variables. So now let's run this. So here what we're doing is we're declaring the first name and then giving a value to it. So assigning a value. That's like a set operation in C#. And it happens from the assignment happens from right to left. So you're gonna have the variable name first, and then the equals, it's the operator for assigning, and then the value. So if you do the opposite, you're gonna get an error because it's telling you that the left-hand side must be a variable or a property or an indicer. So you cannot do it this way. The other thing is that the compiler will check if you're assigning the right the right value according to the data type that you declare. So if you say that it's an int, but then you say Bob with a string, that's not correct. So it will complain to you. Let's keep going. And then, so now we're gonna assign it and read it. So to read the variable, you just use it wherever you wanna. So you can use it on new variables. You can use it when calling methods, so you can pass the value of that variable. And you can see here that you can assign a new value to that same variable many times. So you declare it once, and then after you declare it, you don't have to declare anymore. And then you can assign new values every time. And then, so here, we're showing that if you try to use a variable without assigning a value first, the compiler will also complain because you're trying to use an unassigned variable. So you always have to assign a value, then you can use it. And the other thing you can do is we were doing declaring and then assigning a value. So you can do that all in the same line as well. So you can do string value equals Bob, and then you're declaring and assigning all at the same time. Okay, let's continue. And so there is another special keyword that is kind of like, I can't remember when exactly it was introduced, but it's called var. It's a special keyword in C#, which will let you declare a variable without saying what is the data type. And the compiler will infer by what you pass, what is the data type. So here, it will say, like if you try to set a string and then later you try a decimal, say it will tell you, I cannot convert decimal to string. So once it's set, then you cannot change the data type. And so, so this is the use of var in C#. var sometimes is a little bit contentious. So as you're learning, we recommend that you use the actual data type. but you'll see many examples on the internet about using var, because it's easy. Like, you don't have to type the data type. For the .NET team, like on the runtime, we have coding guidelines, and so we do recommend that we use var when the type is very explicit. Because if you start using var everywhere, it might make the code hard to read and to maintain. So there are special guidelines for the .NET team that var is only used when you instantiate, like when it's very clear what's the context and what's the data type. And in the case of var, you have to declare and assign it at the same time. You cannot do this because it will not be able to infer what's the data type. So we covered that. Let's continue. It goes fast. Time goes fast. Like, there's so much. And so let's see. I'm gonna skip the challenge. Let's go just see the solution in this case so that we can cover more content. So the challenge in this case was to write a sentence that had 3 different variables. So you have a string variable, an integer, and a decimal, and they wanted you to output this. So you can see here that, again, there's many possible solutions on how you can write this. But you can see here that then you can use console write with the different data types, and then it will print a message for you. So let's keep going. Otherwise, we're not going to be able to cover much. All right. So let's do a knowledge check. Jamie, are you ready?
Okay. Yes, I'm ready.
Okay. Which of the following variable names should or must be avoided? Hash, $ data, or registration complete, flag, or yes?
I'm going to say a $ data.
Okay. What is the problem with this line of code? Var message semicolon. That var isn't a data type, that you use the var keyword without initializing, message is not a good variable name, or that variable name message should always be a string?
Ooh, this is a tough one. I want to say... Feel free to answer in the chat if you know the answer.
Let's see. I'm going to help you. So the var keyword, you always have to initialize on the same line. So otherwise you cannot infer the type. And
people in the chat got it.
And then which of the following lines of code creates a variable correctly? So we have an integer with 12.3 M, a string 12.3 M, decimal 12.3 M, or a bool equals single quotes false.
I am going to go with string x equals 12.
Okay. So remember, strings you need, strings you need the double quotes. So.
C.
All right.
Okay, there.
Yay.
Congratulations, everyone. You're amazing.
All right, let's continue. And sometimes, like, I don't use that button to take you to the next lesson, because depending on how many you completed, it takes you to where you stop. So I'm going to make sure that I'm on the right path. All right, so let's take a look at string formatting. String formatting, it's going to be super, super useful for you as you're going to be writing in C#. Sorry. And there are many, like, this is a topic that can go on forever, but we're gonna just learn the basics and some of the neat things that you can make writing the code a lot more cleaner. So the first thing we're gonna look is, and let me see if I put like here. No, it's later. All right. So one is the character escape sequence. So to escape a character, you use the backslash. So this character here, if I can.
Similar to a comment.
Yes, similar to a comment, but the comment is /. So this one is backslash.
Back. Okay.
Yeah. So you like C# will have a different some different kinds of escape sequence. So this is the to show the comment. So we have /n will be a new line. So when you want to format and add a new, like force a new line on the string, /n/t will be a tab. So you can see here that we're again using our write line methods, but then we're formatting. So we're adding a new line in the middle of that string with the escape sequence. And here we're adding a tab. And so what happens when you want to print the double quote in C#? So it's gonna complain if you just add the quote in the middle of the sentence. So again, use backslash. So you use the same character escape, and then it's gonna print a quote for you. The other thing is when you're working with files, file paths, for example, or anything that has a backslash, because it's also for the compiler, it's a special character. So if you do this, it's gonna recognize this. If you're using the string as is, it's gonna recognize this and try to find what is /s. And it's like, okay, there is no escape sequence like that. And so again, you use backslash, and you can escape that sequence. And you can see, like, if I had, like, because /r, let's say that our folder name was Norse instead of Swords, you're gonna see that it interpret as escape character. So it did the new line. So that's not what you want. So you add the double when you are working with that. Okay. So now like your bots ask you to do some code here and you want to format. So here's an example where you start to create a little bit prettier output on the console using the escape sequence. So you have tabs, you have new lines. So it's like making it prettier to output your code. The other thing you can do is the verbatim string. So when you want the compiler to interpret that value as is and not treat them as escape characters, you add an @ symbol in the beginning of the string. So let's take a look at here. So here is going to print exactly as is. So like you have now you can use the single backslash and tabs and spaces in between. And the same goes for paths here. The other thing is that you can escape characters. So Unicode it has representation for all kinds of characters. It's like thousands of characters have different symbols that represent. So in here we're using, it has different encoding too. So it has like UTF-8, UTF-16. You're gonna see that as you go into programming. So for Unicode literal strings, you use /u, and so each one of these is our character. So then you can see that we're now starting to output like Japanese characters here. One caveat here is that some consoles will not display Unicode characters correctly, and sometimes will display question marks. So so you have to have the right encoding set for your console or for your system in order to see the Unicode characters, depending on the kind of character, because like international characters like Japanese, or sometimes even like my name has an accent on the I. So here on US apps, I usually remove it because I've seen many times where that they don't treat that character appropriately, and so it just becomes like weird characters. So I sometimes just don't add the accent to my name to avoid those issues, because I don't trust some developers. And so here, you're using the verbatim and some of the Unicode to run it. So like if we have the full program here, so you can see that it's generating nice formatted code and with some international characters. So this console here it supports Unicode characters. All right. So another thing that you can do with strings is to concatenate. It's going to be very common. You've seen before where we were like doing multiple write line methods to output one string. And so in this case, what we're going to do is use the plus operator, the plus symbol, to put two strings together. So here we have a variable called first name, message, and so we're combining the string with the variable and outputting that. And the plus sign, you'll see that it's going to be used for other operations as well. So with strings, it has the meaning of putting those two strings together. And you can combine many of them together, so you can have as many as you want. And then you can, like when you're passing, you can pass a variable here. You can even go one step further and remove this intermediate variable here and just pass straight the string here with the concatenation. So you can run this, it should have the same output. All right. And string interpolation. I love string interpolation. This is newish. I can't remember if it was C#6 or when exactly it came about. But it allows you to make the formatting of your string much easier to read, because it allows you to put the variable name inside the string without using the plus operator. So this here is equivalent to this. So to use a string interpolation, you use the $sign in front of the string, and then for each variable that you wanna print, you're gonna put the curly braces around it. So let's take a look at the same thing, but now with the string interpolation. So again, here, and if you need to to use to actually print the curly braces, then you use double curly braces. So here, instead of Bobby, it's gonna print the value, because I told that this is no longer the variable. This is like a string. And you can mix and match the string, like the literal with the string interpolation. And you can, again, go through the same process of not using intermediate variables and just go straight to the string you want to print. And you can mix and match the verbatim and string. So here you can use the string interpolation, but also have the the verbatim to interpret the characters as is. Okay. We're going to skip the challenge so that we can keep going. But here we wanted, like, you want to like format, use Unicode and use some variables. So give that a try at home once you go through the lessons by yourself. But we can just take a look and peek at what they had here. So they had two variable names, and you can see like using the string interpolation, using the escaped Unicode and the verbatims here. All right, we're finishing one more lesson. Knowledge check. Okay, so what is the following which of the following escape sequences would you use to add double quotes to your literal string?
D.
Yay. Which of the following lines of code correctly uses a string interpolation, assuming that a variable value is a string? So do you use the @ symbol with curly braces, the $ with curly braces, @ symbol with brackets, or nothing with curly braces?
Ooh, this is tough because I got to get real close to C. Okay.
Let me try to.
Oh, thank you.
So first you need to think like what is the character that you need, like, so we cover verbatim and string interpolation. So there are two different characters, and then what's the format for that?
I'm going to go with B, using the $ and the curly braces within the quotes and brackets.
And then you embedded Unicode characters to present a special message in Thai. However, the message only displays as question mark characters. What happened? So you're missing the /U to escape the sequence. You use the wrong characters. The user's console doesn't support Unicode characters, or Thai can be represented in Unicode.
I'm going to say that A, you're missing. Well, I don't know. No.
Okay.
Maybe
So,
the console doesn't support it.
yeah, because then it's going to print the question marks. All right.
Oh, yay.
We finished one more. All right, so let's go to numbers. I think we have time to do the numbers lesson.
Yes, we do. Yeah, you're good on time, Myra.
Okay. I think we need like a whole day of workshop, because like we're gonna just scratch the surface with C# today, and so be sure to check out all of the resources that we have for you to learn more. So okay, let's take a look at numbers. I'm trying to do that on the video. All right. Okay, so let's take a look.
Yeah.
I'm gonna go to my slides here so we can take a look at some of the operators. So we have some of the operators you can use in C#. So you have the binary operators, so operators that you need two elements to work with. So you have addition, subtraction, multiplication. So you have plus, minus, the star or asterisk, the / for division, and then the percentage for remainder. So remainder, like the modules of a division. And then you have the unary operator, so plus and minus. So unary like work in a single element. So if you want just to have positive and negative numbers, you can use the plus and minus. And then also you can increment and decrement using the plus and minus. So let's take a look at that. So let's run this one. So here we have two integers and we're summing, like you're using the sum. So here, in this case, the compiler knows that because you're working with two integers, then it sums the two numbers and then outputs that. You can also mix and match types for the right line. But what's going to happen is that it's going to it's going to implicitly convert that number to a string because you're using other strings here. So you have first name, and so then this is an integer. So it prints, it interprets everything as a string. And then here, let's take a look at this. So you have widget sold, which is a number, and then another number here. And instead of doing the addition of those two numbers, again, it interprets as it converted. So it converts to a string, it converts to a string. So it printed 77 instead of 14. So if you want to actually if you want to make the addition, you have to tell the compiler what to do. So for that, you can use parentheses. So parentheses in C# will tell you kind of the order of operation. So it's going to execute what's in the inner parentheses first, and then do the conversion. So here, then you now get the 14, the result of 14. All right, let's continue. So let's look at the math operator. So we already went over. No. Let's just run some code that has some of those. And so you can see what it looks like. So those are the binary operators. So addition, subtraction, multiplication, and division. And so you got the results there. And then if you need, so notice here that when you're doing divisions, you're working with integers here. So you get 1. But what if you wanted like the exact number? So then you can use a decimal type. And one thing to keep in mind is that for you to get a decimal result, one of the operands has to be a decimal. Otherwise, if you just do this and assign it to a decimal, it will still be an integer. So one of the operands or both will have to be a decimal. Okay. And then if you're working with numbers, but then you want the result in decimal, you can do what it's called a casting. So a casting is like you're telling the compiler that you want to explicitly convert. You're telling the compiler to convert that variable to a decimal. Otherwise, if you do two integers division here, then you know that you're going to get an integer result. So you can put the type that you want to convert it to in front of it in between parentheses. And then here you can see the remainder operation in use. So you can see how like the modules of the division. And C# uses the order. I haven't learned this acronym in school. I didn't grow up in the US. So, but it uses what's called PEMDAS. So it's parentheses, exponents, multiplication and division, addition and subtraction. So that will be the order that C# will follow, except that for exponents, we don't really have an operator. So we will be, you can use a math class that has a POW method for exponents, but we don't have an operator in C# for that. And so here, let's take a look at this and see the order in play. So here, as we said, multiplication comes before the sum. So here it's gonna do this first, 4 times 5, and then plus 3, 23. And then in this case, you're telling it to enforce the order. So parenthesis comes first, and then the multiplication later. You can also use the increment and decrement, so the unary operators that I showed before. So these 2 lines of codes here are equivalent. So if you want to add more numbers to the same variable, you can use this operator, the plus equal sign, and it's gonna add 5 to the value and then assign that new value back to it. So it's equivalent. And the other one that is very common to be used as well is the increment, so plus plus. So these 2 are equivalent. So value equals value plus 1. So when you want to add increment just by 1, you can use the plus plus. And then the same goes for decrementing a value. So here, let's take a look at this code. So here you have, it's showing like all of the same, like all of these are equivalent. So you have value equals plus 1, and then this one is adding 1 as well, and this one is adding 1. So you can see how it gets cleaner as you're using the increment operator there. And the same goes for the decrement. So the other interesting thing with these operators is the position of them. So it is important. So you can use the plus plus and minus minus in front or after the variable name. So if you use it in front, it's gonna do the operation before, and then it's gonna read the value. And if you use it later, it's gonna read the value and then do the operation after. So in this case, we started with value 1. We incremented its value by 1, so should be 2 here. So we print value first 2. Then here we have value plus plus. So it's gonna read first and then increment. So you can see that the value is still 2 when we print, and then it's going to become 3 after the printed, like after the read operation is over. So then third, please prints 3. And then in this case, we're incrementing before we read. So we're going to do plus plus. So it's going to increment to 4, and then we print 4. So it's important to know like kind of the position of the operator in these cases. Okay, we're going to skip the challenge. Okay, but it's a cool challenge. You kind of have to, like, you're gonna want to convert Fahrenheit to Celsius. So let's run it just so you can take a look. And so you use parentheses and decimals so that you can get the temperature converted. So you do first the subtraction and then the multiplication. And one thing you could do here, like you could convert that, like, so you can start using like the things we learned, like string interpolation. One thing that I didn't cover before is that formatting strings is like a super dense topic. Like there's so much you can do. But for example, just to give you a sneak peek, you can format using you have formatters for strings. So in this case, you wanna, for example, not display all the letters. So there is a formatter for you to reduce that. So you can, like, there's documentation, there's like a list of things that you can do. You can format date times, you can format numbers, and all kinds of different data types. All right, so now let's check time. What will be the result of the following line of code? So 5 divided by 10. Console write line. You're muted.
Whoops. Let me unmute myself there. I'm going to go with B. But is it doing 5 divided by 10? So it'd be A?
B. The third one.
0. Okay.
Oh, let me go here. Yeah, because you have to, like, 5 is less than 10, right?
10.
And then because you have 2 integers, you cannot get
It's going to give you a 0.
the decimal point. And then which of the following lines use the addition assignment operation? So is it the plus equals, the plus plus, this line with equals, value plus, or the the %, double %?
B.
So this is the increment operator. So the one that does addition and assignment is the
Addition.
first one.
Okay.
All right, so let's try. Okay, we can continue. Okay. Do we have questions, or what is next?
Yeah, we have a few questions. Let's go ahead and answer some of those. So is math a module and POW a function?
So in C# language, math is a class, and then POW is a method. So, but the concept, like what they're thinking, is correct. It's like module and function, or but we usually refer them as class and methods in C#.
Class and method. Okay. We have another question. Oh, this one's going to be a bit challenging.
We'll see.
Let me try another one. Unless one of the moderators can pull up the question for me from Frank. The number 1 is always assumed when using plus plus or minus minus, correct?
Correct.
You couldn't type something like plus plus 2 or 3 minus minus.
No, that's only that kind of operator. Like when you're doing loops and things like that. I think that's kind of like the most common use case when you're like doing while loops or for loops, or things that you want to increment where you're iterating through values. I think it's the most common case.
Okay. From Twitch, we have a question. Why should we use minus minus var name / or plus plus var name, but not var name minus minus / var name plus plus?
I don't know if I understand it. So let's see.
Yeah, it's posted.
Let me hear. Why I always forget use. So you can use both. I think people more commonly use the after, the one with the after, not the one before. I think it's just more common, but yeah,
They both work.
They both work, yeah.
Okay. This is backtracking slightly, but still covering this portion of the session. Mm-hmm. Is there a requirement to use Visual Studio Code to write C# console apps, or do you need to install the SDK?
So you need the SDK.
Okay.
Yeah.
Okay. And I can make sure to link that in the resources so people have direct access to the
SDK. And so, and for people that want to learn, so we on the Donna website, if you go on the homepage, we have a get started. So here it's going to get started on the browser, but on the homepage here, our Hello World will be creating on your machine, and so you can install the SDK. So we'll have links for you to install the SDK and kind of check. So like the commands I was writing before, like Donna run, that kind of thing. And how you create the app. And I'm also planning to add some Visual Studio Code steps, so that should be coming up soon, where we're gonna add some links to install VS Code and open that code in VS, so it's gonna be easier for folks to follow along, because we get some feedback that for completely new beginners, sometimes it's confusing where to find the files and where do they go. So I think adding the VS Code here to this tutorial will make it better. But let us know. We are always looking. We have the feedback button as well. So if you go through the materials on the website and it's confusing, let us know, and we'll make it. We'll try our best to make it less confusing and approachable to beginners, because that's why we want to make sure that we're doing it correctly.
Yeah. And Myra manages the website. So if you really do have any feedback, it's going directly to the source right now. Yeah, feel free to put any of your questions in the chat. We'll try to answer them as they come when we take more time. I'm not seeing any currently. Oh, I got one more. And then we can move on to the next. Does var impact the speed while executing any C# program?
No, because when it's compiling, when it's building, the compiler is converting that data type to the actual data type. So when the program is generated, it will already know what the type is. And so in terms of performance, it should be the same.
Okay. So it's not going to slow it down at all?
No.
Okay, so what's next on our agenda? What else can we learn about C# for beginners today?
So we have methods from the library, so we can go. Let's try to go quickly over this one.
Yeah, let's learn about calling methods.
So .NET, which is the platform where you can run C# on top on, has a vast library of classes and methods for all kinds of use cases. So if you're building web or all kinds of data types, so start Googling or Bing, use your favorite search engine to kind of find your way. And so a great resource for that is docs.microsoft.com/.net/API, and you can see all kinds of classes and methods that we have there. So we have a browser, an API browser. So that's kind of where I recommend. Our latest version is .NET 5. So you're gonna find, so you can start like the console class that we were looking at before, for example. You can find more information, examples, and things like that. And you're gonna see the all kinds of APIs are documented there. All right, so we've been using the console class so far, and the write line for as kind of the method. So there are two kinds of classes in C#. So let's take a look at a different kind of class. So here we have a random class. So random is responsible for generating random numbers. So here, for us to call a method on the random class, we are actually having to instantiate a class. So we're gonna use the new keyword. So we're gonna do data type, name of your variable, equals, and then new. And then we can call the methods from that class. So why is that? So there are two kinds of classes in C#. So here in the module, they're referring as stateful versus stateless. So the console class or the math class, they are stateless. You don't need the new keyword. You don't need to define and you create that object to be able to use that. That's because those classes, they don't depend on the state of your program to know what to do. In the case of random, it uses some computation and some data like timestamps and stuff to kind of use the next to really be random. So this is how you create an instance of a class. So remember when we were talking about like the basic object oriented, we had the class and the object. So when you use the new keyword, you are creating a new instance of a class. So that's your object. So you created a dice object here. So in C# when you're looking at a class and you want to see if it is stateless or stateful, the keyword when you're looking at the API documentation for you to look at is static. So in C#, static classes are the ones that are stateless, so that you don't need to create a new variable to use it. So in case of console, or if we go to the math class, it should be static as well, if I'm not mistaken. Yeah, and so if we go to the random class, then you're gonna see that it's not gonna have that keyword in the definition. So it's called an instance class. So you need to create a new instance of that class to be able to use it. And so, so if you try to do that, this is like trying to use the random class without instantiating, you're gonna get a compiler error saying you need an object reference. So the compiler will help you to navigate that scenario and define like, do I need to instantiate or not? So you can give it a try, or you can consult the documentation for that. So the methods can be return value or not. So some methods, they will be what's called void, and so they won't return numbers or won't return any values. Or in the case of next, so let's look at the next. Method. Let's get to the methods. So next, so you're gonna look here, and then it says returns integer. So if it wouldn't return anything, it would say void here. So in this case, it returns an integer. So you know, so you can do something with that value. And for input parameters, if you have more than one, you have to use commas to separate them. And so let's take a look at this. So the other concept is overloaded methods. So each method has a signature, which is defined by the data types of its parameters, and then the number of parameters. So if we go to the random next page, you're gonna see that we have 3 overloads. So we have one with no parameters, one with 1 parameter that specifies like the maximum value, and then here you have a range of minimum and maximum. And so in this case, we're using the console write line. The console write line also has several different overloads. I think it's like 19 or something, one for each type. So you can see, like, as I scroll here, that it accepts like array of chars or decimals or doubles. So that's why we were able to pass different data types to the write line method. So when you're calling a method, you want to make sure that the parameter you're passing matches the expected type. And then each each method is implemented in a different area. So it's going to have its own rules, and it's going to have its own code. So here is the different next, the random next methods being called. So like the three different overloads that we have. And so here, it's telling you the maximum random number that we want. And here we say that we want a number between 50 and 100. So because one thing that you also need to look into in the documentation is like, what are kind of the rules for this parameter? So if you go here to the next one, it says that it's an exclusive upper bound. So it's not going to include that number on the when you call it. So 101 is not going to be one. And then IntelliSense, as I showed before, like it's going to help you with doing with coding. And so one thing you get when using IntelliSense is you get all the methods that you have or properties that you can use for that. And then you also, let's see if I have in VS Code, I have the IntelliSense. So here you get the description of what is each parameter and kind of the basic documentation that you saw in the docs. You have in IntelliSense as well.
That's nice that it's integrated right in.
Yeah. And the difference between what's in IntelliSense and what's in Docs is that Docs will have like examples and sometimes remarks. So those won't be part of IntelliSense, but the minimum description for what the class does, what the method does, and each parameter will be there. Okay, we're gonna skip the challenge so we can keep going. Do we want to take questions? I want to make sure that we are right on time for things.
Yeah, let's do the knowledge check and then we'll take some questions.
Okay. All right, so what is an object? A memory address, a static method, a stateless class, and an instance of a class.
A static method?
The object, remember the blueprint, the blueprint.
Oh, yeah.
Yeah, so it's an instance of a class. And I think someone asked if you are truly learning programming here with me, and you are.
Yeah,
right? It's not. This is not fake, folks.
Yeah, I'm not pretending to not know the answers. I swear. Okay.
Then,
yeah.
So which of the following statements is true? So the library always defines overloaded methods or contains. So the class always defines overloaded methods for every method, or you have the library contains definitions for data types. The library uses namespaces to simplify your code, or the library contains methods that don't belong to any class.
Okay, see if you can beat me in the chat. So
let's see what folks are saying here. Oh, my comments.
I want to say B.
Okay, let's try. I don't know what happens if you get it wrong. Does it tell you? I don't know. Let's see.
I think it gives you another chance.
Okay, let's try.
We're pretty easy here.
And which symbol is used to call a method? So when you execute a method, which symbol do you use to invoke a method? Like when you need to call, like how do you pass the parameters and stuff like that? Like what symbol do you use? So let's see. what it tells us.
Or brackets. Oh, does show that you got them wrong. Okay. So then maybe C is what I wanted to say.
Yay! Oh,
There
yeah.
we go. We did it.
So,
Amazing.
I haven't done this
everyone.
knowledge check before. So when you complete on Learn, you get points. And so we got some new points and experiences. And then you can unlock achievements and things like that. So like it tries to make it fun for you to learn as well.
Amazing. Yeah. So if you did complete it, congratulations. You all are amazing. If you didn't get a chance to follow along with us, please feel free to do it in your own time by going to the resources for this page. Also, we're doing, don't forget about the Learn Challenge, where you can win prizes for completing the C# Learn Challenge. But Myra, I feel like we're getting some static wave on this stream right now. Did we just get someone to Scott Hanselman?
Hello.
Yay!
How's it going?
How are you?
I'm very well. I'm very well. That was a very sneaky test. I don't approve of that.
I know. I was like, wait.
That was a hard one.
Yeah, no, that because I was looking at that kind of backstage, and like the method invocation one, I was like, oh, it's the dot, and then I was like, well, okay, so not really. What makes it run? It's kind of a weird question. I don't know if that's a good question, but it's interesting because it's like when you're learning English in school, right? And it's like, find the noun. You're like, is that an adverb? And you're like, I don't really use it in my everyday life. I don't think about it like that. But now that we know it, we're like, oh, okay, yeah. I mean, the parentheses are really the call the method, and you put your parameters in the parentheses. And the dot, that's the thing that gave you the list of methods.
Yeah.
Sneaky.
That was a bit tricky. For everybody who got it in the chat, you're fantastic. So Scott, we're talking about C# today, and I hear you're a big fan.
I am a big fan. I have been goofing around on TikTok for 25 days. If you want to see my giant forehead over and over and over, day after day after day, including fun programmer humor. When you're doing generics, I don't know if we got to that far in this particular.
No.
When you get into advanced C#, you'll do things like, you'll make an object, like we made some objects, like a person, and then you'll put them in lists, and then you'll say list, angle bracket, person, close angle bracket, and the angle brackets look like this. So you'll say list of person or list of pets. So that's a cup of tea. And that's one of those little programmer jokes that you'll get when you learn C#. So when our friends who are watching start getting deeper and deeper into C#, they'll learn those things. So I was promoting this wonderful thing all month long. This is harder than it looks, and I eventually gave up on day 25. So I apologize. I got really tired and I couldn't do any more.
But I was watching it this week. It's super cool. It gives a taste of things that you can do with C#.
Yeah.
And yeah, I feel like we need to do more of these events because we just scratched the surface on data types and not even we didn't even get to loops yet, and things like that. So,
yeah. Well, this right here, Myra, is the actual program that we wrote over the last 25 days. Now, again, it's only a minute at a time, so it's really a couple of minutes. It's much shorter than even this workshop. But here we have some using statements. We saw namespaces, right? Did we talk about classes?
We talked about classes, yes.
Okay. So I did something interesting here. I thought we've got first name and last name, right? So there is a string first and a string last, and this isn't a really good example of a person, and it brings up a really interesting thing that I think is worth pointing out. It's not C# specific, but what about people with middle names? What about Prince? What about people with 10 names? When you design an object, you're really saying something about the space you're working in. When we talk about inclusion within the context of programming, I just decided, first name and last name. And someone was like, but a lot of people have 6, 7, 8 names. Some people don't. I saw a thing on Twitter recently where someone said that a name has to have 3 characters. And then someone with 2-character name showed up. And I was like, wow. So all those kind of interesting analysis things you get to think about when you're doing things in C#. This was an interesting one. What do you think about this, Jamie? Take a look at the relationship between birthday, which is now a date, and then what's going on here with age. Because birthday and age are different things. Because I used to store the age, and then I realized I don't want to store the age.
So he's calculating. Yeah, he's calculating based on the other.
Right. So this is a property that stores the birthday. So then if you ask me what your age is, I'll just look at today and the year for today, and then I'll subtract the birthday year and get back your age. So this is called a calculated property. And this is a property that stores stuff. So you store the birthday and you calculate the age, which is kind of what humans do as well, which is kind of cool. And then I can do this. I can fold these up. See how I can hide it? So it's there, but the editor is hiding it. It makes it simpler for me to see, which is really cool.
That's an interesting class name down there.
Oh, yeah. I wanted to point out that the names don't matter. And here, look at this. They said, this is the best part. It's a violation. I'm like, oh my goodness, a violation? Well, it turns out it should be uppercase poop. So very important analysis there.
Case sensitive.
I made this URL here, this URL. It's actually using my own personal tiny URL, Hanselman. And this is a list of people. Okay, so I made a little web service, and I've got all the important people like Beyonce and their birthdays, and I put this all on one line. So this actually is one long line, but you can split things up, right? Because I think we learned that C# doesn't really care until you get to the end of the line. So this is one line. And this is also one line, but I just put them on 2 lines for reasons.
Yeah, so we were talking about statements, and the end of the statement is the semicolon in C#. So that's how you know when it ended.
Yeah. Oh, I'm so sorry. I think Fritz is telling me that I'm not using the microphone in front of me. Well, golly whiz.
You sound good.
Well, now I sound better because microphones. Technology.
The experts.
I apologize. I was using this microphone over here. Thank you for that, Jeff Fritz in the chat. Apologies. My apologies. Yeah. So here we're like, I'm going to HTTP client. I'm going to basically be a web browser. I'm going to call HTTP, and then I'm going to say, go get me some JavaScript. And remember that cup of tea? Here's a list of person. Go get me a list of person from here. And then we didn't do for loops, right? You said?
Yeah, no, we didn't. So we didn't get to that.
No.
They're kind of intuitive, though. Like, for all of this stuff on the shopping list, go to get them at the store and go in the aisle. So for each aisle, for each shelf. And you can imagine things like nested shopping lists. We do this in our regular day. If I have a list of stuff I'm going to get on the weekend, for each item, right? Find the store. When I get to the store, for each aisle, for each shelf on the aisle, I can go and search through all these things. You can imagine having nested for loops. And we do this in our regular day. And when we teach them, though, people make it really simple, make it really hard. Like, oh my goodness, it's so complicated. You're doing complicated stuff as a human. For each piece of mail that I got in the mailbox, do something. So all this code does right here is spin through my list of people. So I'm going to go ahead and put a little red dot here, and that's going to have me basically run the program. I'm going to stop when I hit the red. So I'm going to hit the play button here, and what I'm going to do is I'm going to bring this over here, and I'm going to snap and then snap. So we're going to have 2 windows here. It's going to look a little scary for a second, but it's not too bad. So we're in the middle of running a program. We've done this part, and we're sitting here waiting on the yellow for the next thing. And then I can just go, I'm pushing a button, 1.
Oh. I think we lost.
Did we lose him?
Did we lose Hanselman? He made it sound so easy. 1, 2, push 1, 2, and you're off the call. That's all it is.
Unfortunately, I don't have his code, but I could show like the debugging here as well. And someone was asking if his videos from TikTok are posted elsewhere. I believe he's also posting on Twitter, if I'm not mistaken.
Yes, he does repost his Twitch videos to his Twitter account. Oh, whoa! Did you see you were there in 2 different places? That was awesome.
My computer crashed.
It happens to the best, right? Like even the pros.
To the best of us.
Look
It's a
at this.
live event.
I've never seen a crash like this. It's like weird blue thing
It
going
went
on.
out.
Like this monitor's still on. I think it blue screened. I have no idea what's happening.
Okay, but you're back.
This is why I have
You're back now.
This is why we have 2 computers, right? So I was like, oh my goodness. And I run back over there. But sorry for that crash. I'm not sure if that computer's sick or not, but that was an example of the stuff that we did on TikTok. And we've got the videos on .net/videos. We've got the tutorials on Microsoft Learn. There's so many cool things and so many people out there that are ready to help you be successful in writing things in C#.
Yeah, someone was asking if there are more lessons. So we, like, as I said, we just started with the first lesson. So there are more modules. You can learn about web API and like web applications, microservices, and we are adding new lessons like every month or every quarter. We're working on new content. It takes some time to create new lessons, but we're investing heavily in having that content for you.
Yeah, definitely. All of this information from today's event will be on the resources link. If we could pop that up really quick. Thank you very much. So all of the documentation, all of the Learn modules, the C# page Myra is building with all tons of new content for C#, also available in this resource. Follow Scott Hanselman on Twitter and TikTok if you'd like to learn more about beginner basics in C#. You post those on your Twitter, correct, Scott? You repost your
because TikTok is not available in every country. So
Mobile.
all of those are on a Twitter thread, and I'll probably stitch them together into a YouTube as well. There are so many resources out there on the community page on .net. Like, we want people to feel like there's a human out there that cares about their success and is available to help them.
Yes, absolutely. Well, thank you so much, Myra, for joining us. That was amazing. Really, really great run through. Hanselman, thanks for the surprise. We always love to see your face around. Everybody who joined us online and all of our watch party, hello, watch party. Thank you so much for joining us, taking time out of your day to spend it here with us. We really, really appreciate it. We hope you learned something and that we got to build something together. Thank you so much. Join us next time on May 21st for accessibility. 8:30 a.m. Pacific. Thanks, everyone.
Thank you.
Bye.
On some of the learnings that we have on the .NET website on how to build your first microservice using .NET.
Amazing. Well, that sounds really exciting. Before we get started, my name is Jamie Singleton. I work for the community team on .NET. I'm joined with my coworker, Shane.
Yeah, and I'm a principal cloud advocate on the DevRel team or advocacy team, and I lead the .NET and mobile advocacy space.
Amazing. So, Shane, tell me, what are microservices?
Yeah, so that's a good question because there's a lot of terminology that surrounds microservices. The word micro intends it to be small, but it doesn't mean it needs to be small. It's really about taking monolithic applications and breaking them up into smaller, more deployable, and kind of single principal responsibility item. So if I have like a customer service that's just getting my list of customers, I might have an API related to that service as well as a database backing store. And that is a single deployable unit. And what that allows me to do is to make iterations on that and do deployments independently of the other parts of my application. So I think in a few words, it's really about single responsibilities of a service in the backing store and not interrupting or causing breakage in the rest of your application. So you can start by architecting your application that way, or you can start to break off pieces of monoliths into that thing. And I've got a slideshow that we can go through if you'd like to kind of walk through some of these points, right?
Yeah, that'd be excellent.
Okay, let me see if I can share my screen correctly. And let me get it up into the right place and hit the right button. Okay, how does that look? Are we good? All right.
Yeah, I can see it.
All right, awesome. So we already talked about who I am. We've already asked this question. So here's kind of an idea. We've got a monolithic app. This has all of our items in kind of one piece, meaning that it's deployed as a whole. It's huge. It's got a ton of moving parts, and they're all managed in maybe a single solution or a single project if you're brave enough. So to move the containers, recently has really made all of us kind of rethink our software architecture. And the industry itself, over the last, I want to say few years, but it's probably longer than that now, has really started to embrace that pattern for building scalable, reliable services. That's one of the advantages for us to have these microservices. A good little example is I use a customer service. Let's say that I have an order service that's also associated with my application. I can scale that independently of like my customer service, because I would expect that my order services, if I wrote a really good application, would need that scalability. And I can just scale that one piece of the app without having to scale the entire application, which may not need it, and consume additional resources. So as I mentioned, they're independent, they're immutable deployments within containers. And we'll talk about some of the tools that we use in order to manage and create those. My next statement is it says it's small. Now, they're scalable and small in the sense of the responsibility of that service is small. But it also allows your teams themselves to be small as well. So as our applications grow in size, there might be multiple technologies used for each one of those services. So I can have a really small team that just does .NET. I might have another team that's focused on Go or the front end, and they can just work on their one little specific thing without having to have the knowledge of all of the other tools that we're using and the stacks. It's I would say it would be a challenge for us to find somebody who had a breadth of in-depth knowledge across all the types of technologies we're using in an app. Microservices themselves, it's really an architectural style that has these collection of services. Again, they're loosely coupled, and loosely coupled meaning that's that independence that I talked about. Like I can do my order service by itself. I can scale that and deploy it as I need to. But it's also organized around the business capabilities. I don't have one API that has a surface area that covers, marketing and ordering and my shopping carts and location services. All those services should be independent by themselves again. Now, as this relates to .NET, we took an approach with .NET Core to make it, it was built really for the cloud and suited for this type of deployment and development. And we can walk through a couple of those things as we go through some of our examples. Now, is the monolith bad? No, no monoliths are bad. I bet all of us have something installed at work or on our current computers that is a monolith and we wouldn't know, and it operates just fine. Many of those apps are still exist today, and they were created, outside of this independent deployable stuff. And you don't need to migrate all of your apps to a microservices type of architecture. If it's not broken, don't fix it. But there might be a piece of your app that does need to scale independently, and that's where you can kind of take advantage of breaking that service off into its own thing and make it scalable outside of the entire app itself. This is kind of a traditional diagram of what a monolith looks like, or what we've probably developed over the last many years, where we've got a web app or a mobile app that hits some API, and the API has a number of these business DLLs that we just make reference to, and they work on a single database. When we move to a microservices architecture, we start dealing with things like API gateways, which is really a facade over all of the other underlying services. Or aggregator might be another word for that. There's also a database per microservice. Now, the diagram here shows that a single database per service, but that could also be a schema within a larger database as well. So it is a specific chunk of your data stores that's related to the service itself. And that as well should be able to be kind of independently migrated to the next versions as you move forward. Async communication, there's HTTP, as well as gRPC is another protocol that we can use for our services to talk to one another, and or like things like event bus.
An important one.
Yeah. So what is a container? Let's talk about that, because we hear that word a lot associated with microservices and deployments. And when we look at something like a VM, which I think most people now in the industry would understand what a VM is, it's really just a virtualized piece of hardware. And in order for me to scale it, I have to create another VM. And the time to create those is a lot by comparison to something like a container. A VM can scale, in best case, probably a couple of minutes, where our containers can actually scale in milliseconds. So the containers virtualize the operating system, and the applications themselves is that unit of work. That's what we're scaling itself. Now, in a traditional, kind of virtualized environment, we have the agility across the teams and things like that. And you'll see that our VMs have basically this stack of where the hypervisor sits on top of the host and the hardware. You do have a limit to what this can give us, all the way down to the hardware itself. We have, again, the low utilization of the resources, and in a containerized, missed a button. In the containerized application world, we can put all of the containers in a virtual machine. Everything still sits in a VM, but it can be a very large VM. And the container itself, is the application itself, is the only thing that scales. I don't have to scale the host OS as well as my application. So they're deployed independently of the host. The containers really have a hook down into the host OS themselves.
So, I like this visualization you have here.
I can't take credit for that. Nish on our team is a master at doing this, and I appreciate his help. So as we start to scale our application, the unused resources kind of scale as well. They go up and down. So they're lighter weight. They can be scaled easily, and I can move my application to multiple containers inside of a single virtual machine instead of having multiple virtual machines to manage. So that's a big advantage as well. And a cost savings too, because if I have, I don't know, 10 VMs, that's going to be much more expensive than a single one running in multiple containers. Here's a statement from Gartner that they expect that more than 75% of our organizations in the world will be running their apps in a containerized production environment. So just to talk a little bit about the growth, Kubernetes is another fun word that we hear about in the microservices world, and that's really the platform where you deploy these microservices type of applications. You can deploy containers themselves onto things like App Service in Azure and run a couple of containers there, but when you get into large scale, there is a kind of a step up to things like Kubernetes on Azure Azure Kubernetes Service. And you can see just here, Kubernetes is in production in many recognizable companies, and there's hundreds more than what's there. And we can also run on any platform, right? Obviously, we prefer Azure, but if you have an application that is currently running in one of the other vendors, that support is also there and is agnostic to the vendor. There's no vendor lock-in. And it's an open source project as well. Huge community of people continually supporting and building up this service. So we have a couple of resources, and I think that we'll supply some links as well. We've got a number of ebooks that are free to you to learn how to kind of step this up in some of the bigger applications, how to modernize your app into containers if you're currently running on a Windows platform, et cetera.
Yeah, we actually just released all of these new resources over the last month. On the event page, there is the aka.ms/microservices_resources, where you can find links to all of these, as well as all of the links for this event as well.
Yeah, and I see in a couple of questions here. Let me get out of this slide deck so I can see what else is going on here.
Yeah, you ready for some questions?
Yeah, let's do that.
All right, let's go ahead, because we got some good ones in the chat. So. And feel free to post your questions in the chat channel. We are monitoring that, and then we'll go throughout the event and answer those as we get them. So a real good question here by Ismail is, can a monolith web API talk to a microservice, or must you use Docker?
Yeah, I think the question is interesting because, yes, if I have a big monolith and I want to create a microservice. Now, microservices means that I'm actually running in a container, and that allows us to do that deployment and all the architecture we talked about. Your application conversations will happen across HTTP or gRPC. You can, if you can basically see the app either via IP or name resolution, you can talk to that service. It's just like developing any other services that talk to one another. The question of, do we have to use Docker? Not necessarily, right? I can create a single deployable web API app that I can run on App Service, and I can scale that. But you don't get the benefits of this very, very small and kind of automated scaling that comes with some of that, some of the container technology that's out there. All right.
I see. I have a couple more for you.
Sure.
Irving at Olympus asks, how do databases work with microservices? Are they using the same database or different databases?
Yeah, good question. I don't know what popped up on the screen. Another different question.
Is that a different question?
It's a different question. So I'll answer the database question first, because I did talk about it in the slide presentation. The short answer is yes, meaning that it can be its own database. Or it can be a schema within a big database. And if you look at some of the database platforms that are out there, they may be able to give you the opportunity to break up your database tables and stores into its own schema, so they can kind of operate independently, but inside of a big box. Now, as far as databases, different databases, this comes into, like, maybe I'm running SAP or some HR system that I don't control. I might have a service that just talks to that one thing and exposes the functionality for me.
Okay, I see now. So we have another question by By Reactland was actually our first question. So
Sorry.
are microservices and serverless basically the same in the system design view?
Ah, good question. So serverless, and in our world of being Azure Functions, it does certainly fit into the microservices architecture, because that it's its own thing, right? That you might have an API built specific to a task in serverless. It gives you the scalability. It gives you the responsiveness and things like that. What you don't have to worry about in the serverless world is I don't have to care about any servers, right? Kind of like one of our colleagues, Jeff, says, serverless just means I don't care about the servers. There are servers there, but it does allow you to not have to worry about what OS I'm running on or what do I have to allocate for memory or anything like that, because that's all taken care of you for the platform. And you would actually communicate with those via HTTP call or gRPC. In the serverless world, we have our it would be via HTTP for now. And it's just like calling another web API.
Okay. Okay, we'll take a couple more questions and then we'll get going. So,
Okay, perfect.
Alexandros asks, are microservices a good option for fast development?
Yeah, fast is relative. I would say it's good for focusing on one responsibility of your app, so you're not distracted by what is my front end doing, what is my back end doing, what is that other service doing. So when you're trying to focus on, again, just the order service, that's all I really have to care about, because there's no dependability between the different parts of your application other than just some sort of a URL call that happens out there. So I think that fast, yes, there are things that certainly will increase your velocity as a developer, to use a DevOps term, when it comes to building out applications.
Okay, I'm going to ask one more here before we get started on the next, on the first workshop.
Sure.
Basant asks, in which scenarios should we go for microservices?
Yeah,
that's a loaded question.
It's a loaded question. It's going to be things like APIs. It could be anything that needs to do work to support another application, but you need to think about, how do I organize my services around my business capabilities? So if you need the scalability, the high scalability, ease of deployment. So when you get into DevOps for microservices, they're super easy to deploy. I'll give you a quick example. I'm sure nobody who's on this call with us or this presentation with us has ever had a problem where they had to roll back an application. That's where I see this as a big advantage. You'll see how we kind of tag our containers and our images as we move forward through the demos. But imagine if I have to roll back a deployment, if all I had to do was change a version number in a configuration, and I could restore my app to its previous state. That's a big deal, because typically you're uninstalling things, reinstalling things, turning machines on and off in the right order. A lot of, what we used to do in the past type of thing.
I see.
All right.
Okay, so we'll continue to answer questions throughout the event. So quickly, I just want to give a quick couple shout outs. One, we are still doing the Learn Challenge. So if you have heard of the Learn modules, we're doing this Learn Challenge where you get to complete the modules and you get prizes. It's really awesome, complete with the badges. So there's the link right there. Feel free to go ahead and do that. I also want to give a shout out to our watch party. Hello, friends. Thanks for watching. And I think we have the link posted for the next workshop. So we're going to be building our first microservice.
Yeah, I think let's do this. We can share my screen here and wait for that to come up. There we go. Perfect. So on the left is our microservices with .NET. I think we have a link we can share. that'll point you there. It's underneath the ASP.NET area within .NET. And there's a nice button here where there's a lot of information about kind of what we talked through already about why and what and those good things there. And there's even videos on here. There's some guy, I think I know who he is, how to build things with Docker and stuff like that. But what I'd like you to do is go and hit this Get Started button, right? So when I click the Get Started button, it's going to take me to the very first tutorial. And that's kind of what we're going to walk through today in this first workshop here. So we have our intro, and it talks a little bit about what the prerequisites are for the intro. Nothing. You're here. Okay. The intro is watch this video, which we're not going to do. We're going to skip ahead. So let's get started with that.
Feel free to do the watch the video in your own time. Highly suggest.
Yeah. Give me a thumbs up. That would be great. So the first thing here is to install the .NET SDK. Now, we have a link here that'll take you to your platform specific download. It doesn't matter if you're on Windows, Linux, or Mac. I'm going to be running through, I'm on Windows today, and I'll be using PowerShell. So once I do the installation of this here, like actually, let's open that new tab. Oh, look, it downloads the exact SDK. Awesome. So let's cancel that. It'll install it for you on your platform. And we can just see here, actually, I'm trying to type in the wrong window. If I said .NET, we know that's installed here. I can also say .NET, let's see, -- version. And I'm using 5.0.201. So your latest one will actually get downloaded here. You might be on a different version than I am. I've got a number of things. So let's get out of that. We don't have an error, so we can say continue, which is great.
Already doing great.
Yeah, already doing great. So the first thing that we're going to do is create a very simple web API. And this is kind of representative of some of the things that, some of the scenarios that we've covered in things like a people service and such like this. In this particular case, we are just going to create the out-of-the-box weather service that comes with the example. So I'm already in my my working folder where I want it to be, and I'm just going to do a .NET new web API. And the O tells us the output folder we want to put this here, and we want my microservice. I'm sure nobody's done that before. And I'm going to do in a flag for no HTTPS. Now, I'm using VS Code and doing terminal, but there are other tools like Visual Studio, obviously, and other community tools that you can go through the same type of scenario with and do like file a new project and walk through some of the walkthroughs. But the options themselves are exactly the same. By specifying the O, it gives me the output folder, but also the name of the application too. So I'll hit enter, and it says it's getting ready. Awesome. It's doing all these wonderful things. And cool. Let me clear that. And we'll do the next step, and we'll get into that my microservice. So now we're in that folder. And we can look at the generated code. I need to just refresh this real quick with the folder. All right, let's close this out. So if we walk through, let me see if I can get a little more screen on here. Okay. So the first thing we can see is we actually go to the controller, the weather forecast controller. Yeah, sure. Let's, there we go. It looks like our typical kind of web API or API type of controller. We've got basically some static summary, some static data here. We're using the logger that gets injected through the IOC container. And then here's our get method. So this is the actual method that we're going to be calling, for today through the actual web browser. So we can continue. We've done that. This is great. It says to run our services. So I can bring up the terminal here. And let's just clear this. And we'll just do a .NET run. Now, there are commands built into VS Code that allows me to do this through the editor. I'm just going to go ahead and do it right here. So let me make sure that I'm in the right thing. There we go. So now we've got our application. We see it's running on localhost 500, and I'll just click into that. And that's not cool. What happened here? We have a failure. Let's try this again.
Classic.
It always fails when you are presenting.
Are live.
Never when you're running through it, right? So let's see.
Definitely not.
I wonder if I have.
If you follow along the tutorial, you'll see that you need to append something to that URL. Magical producer behind the scenes. Pay no attention to me.
Pay no attention to the man behind the. Oh yeah, look at that. So this is the magical error that I always get when I do API development, and I don't actually go to the URL of my API, right? Because it's not on. It's not on the root. It's actually in. I think so. My magical producer reminded us of that. So now we've got our app running. And we've got our APIs coming back. You can see our summaries here, balmy. It's all random. If I hit refresh, we should get some different weather. I would like on days to be able to hit refresh on my weather. So let's get out of that. Let's go back to our tutorial and make sure we follow the instructions. I should have clicked. We ran into an issue. That's what I should have done, right? But we didn't.
We're all learning here today.
I'm learning that after many, many years of doing this, I still can't remember to go to the right URL when I'm testing my APIs. So this can be solved in your tools by setting a start page, which I also did not do. So we'll hit continue. And now we have to install Docker. So if I go and look at what we need Docker for Docker Desktop to create our actual containers and have the tooling that we need locally in order to turn this into what is known as the microservice container for deployment. I have already gone to Docker for Windows. It might say Docker for Mac or Linux, depending on what you're working on. And that will take you here, and you can just say which one you'd like to install. So if I go and clear this out and do Docker version, just to make sure that we're still good and it's running. This is great. So now I have version 20. And I can actually, the next thing I want to do is I'm going to push this to Docker Hub. Right.
Shane, can you explain a little bit about what Docker is quickly?
Yeah, that's exactly what I was going to do. So Docker is, it's an application. I don't want to call it a framework, but it's a way, it's an engine that allows you to run these containerized applications locally on your machine, but also gives you the ability to create the containers that you need for deployment. So it is a really specific tool. They pretty much, I use the containers and Docker as kind of like the word Kleenex and tissue, right? There might be a lot of tissues, but everybody knows who Kleenex is. So it's really just think of it as a tool that allows you to create these containers, run them locally, and then also they have registries and things like that you can deploy your containers to, which is what we're going to do in the next tutorial, not this one.
Okay.
All right.
Great.
And there's Docker tooling built into VS, into Visual Studio through some of their workloads. I have an extension for Docker in VS Code, which allows me to do some easier things like creating my containers, and I don't have to remember all of the command lines in order to do that. If you're using an IDE that we haven't talked about, definitely check out the resources. They may have those tools for you. But at the lowest level, you still need Docker for your platform installed. All right. So
you will need Docker installed to continue.
Yeah.
Okay.
Yeah. So now that got Docker installed, we've verified that we've got it running here. The next thing I want to be able to do is create the Docker file, which is really just a list of instructions on how to package up my application into a container. And we can just use the echo dot here, and we'll say we want to create the Docker file. And if I think it's this, nope, sorry. If I go up to my things here, you'll see we have a Docker file that is in fact empty. And that's what we're going to go ahead and add some content. Now, You could use start to go there. I'm already in VS Code, so I don't need to do any other work here. So let me get out of this. And you'll see in the tutorial that we have a list of instructions, and I'm going to go ahead and copy those into the bigger window, and then we'll talk about it. Paste this. All right.
Would people be able to use WSL instead of Docker?
They can use Docker inside of WSL. Right?
I
So
see.
WSL just allows you to run Linux inside of Windows, and Docker does run on Linux as well. In fact, it was created originally for the Linux platform.
Oh, okay.
Yeah. So I've taken the code sample here on the tutorial. I've pasted it into VS Code, and we'll talk about a little bit what this does. Now, the first thing in the line here is a from statement, and it's specifying kind of a URL pattern here. And what this is saying is I need a base image, a base image of the OS and also the frameworks that I'm going to use. And in our case, we're using the SDK for .NET version 5.0. So this is .NET 5 that I'm using. And you'll see that it says SDK here, which means I'm getting the full SDK. It's as if I have downloaded and installed the .NET 5 SDK. And we're going to be using this and tagging it here as build. The next thing here is the instructions say it'll just create a work directory. It's going to copy our CS proj into that work directory and then call a restore to basically do the NuGet restore on our application. Right. The next step here is we'll copy the rest of our app into this container here and then run publish with that same -o parameter to a folder called app. And we're using the configuration of release. So we want to create a release version of it. This is a multi-stage container build, which means I can define multiple from statements in here to do different operations. And the next line here, we have that similar URL specifying the base image that we're going to be using. And in this case, we're using ASP.NET 5.0, and this is a runtime version. So this is going to be much smaller than the SDK by comparison. We're going to, again, set that app, and then we're going to copy. It says from build. Remember, we specified up here at the top, this is our build container. And we're going to copy everything in the app folder to this app folder in the stage here. And then we're going to set an entry point. And what this means is when the container is started, this is the command or instruction that is going to execute on run. So we have the My Microservice DLL. And this is very important because we want to make sure that our folder, our project name is named the exact same. So you'll see My Microservice. See, I already caught an error that might happen. Look at that. Let's go back to the Docker file. So we need to change that. My Microservice. Okay, so yeah, we always validate that because in this particular case, I'm using a Linux-based image, and Linux is case sensitive. So if it failed, maybe just check your spelling of this. So the next thing that we're going to do, if I look at my tutorial here, is create a Docker ignore file. And what this will do is similar to the git ignore, where basically anything that gets copied from, see, we do this step here, copy everything. There might be some files that just are irrelevant, that we don't need them actually in our build or our publish process. So we want to make sure that we include those. So let's copy that command real quick. And let's go here. And now we have this Docker ignore file, which is great. And basically we want to exclude, not dot, that'll exclude everything. These are the things that we want to exclude. So our Docker file, that's not important to our build or our run step. The bin and object folder, also, those are things that only happen on build, and you may have debug and multiple types of releases in there. So they're not important. We don't want to put those actually in the container either. We want to try and keep this as slim as possible. All right, I'm going to pause here. Do we have any questions right now?
Yeah, I think just waiting for a few people's local hosts to catch up, and also as well as downloading the Docker. What terminal are you using? It's so fancy.
So I'm actually using PowerShell, and I've added. Oh boy, it escapes me. So if you go and do a search for our good friend Hanselman, and probably PowerShell. There you go. How to make a pretty prompt. You see mine was purple, right? And there you go. That's the exact same terminal set up. But basically, it just has the Windows terminal. He's using Windows terminal. I have it built into all of my setups here. But this is basically Oh My Posh and some other themes like Paradox. You can actually set it up for Ubuntu and WSL and do the same thing. So a good walkthrough there. I will see if we can share that out somewhere as well.
Awesome. Yeah, I want mine to look that pretty.
I used to run on Mac all the time, and I had all the same kind of look and feel. And what's nice about Windows Terminal is I can run inside of Ubuntu or many other OSs that we have, flavors of Linux in there, and I can make all my terminals look the same or different depending on where I'm at. The nice thing for me is I can switch back and forth between my Mac, Linux, or Windows, and I feel like I'm still in the same space, which is really good.
That's really nice.
It's comfort, right? You have to be comfortable in when you're developing
in your environment.
Yeah.
Just quickly before we move on, is Docker a specification or an implementation of Linux?
Docker allows me, if we go back to our Docker file here, I would say neither, if I understand it right. What this does is allow us to say what we're going to use. If I actually go and look at the container for .NET SDK 5, and I kind of look at all of the layers that exist for it, we'll get down to actually an Ubuntu image that we're using. So we're building on top of Linux. But what Docker does itself is allows us to specify instructions in order for building our app inside of a container. You can also do Windows containers as well, but those are a little larger in size. They're I want to say they're right about 1.5 gigs, maybe 2 gigs, where this particular image is going to be somewhere, I don't know, in the range of 20 megs. So it's different there as well.
Okay.
All right. Let's jump to the next step. Let's actually see if we can create a Docker image here. Let's pull my terminal up here, and we're going to clear the noise. So the first command it tells us to do is a Docker build -t my microservice, and then passes a dot. Now, if I type this in here, I say Docker build, and this is very similar to like a .NET build. We're just telling Docker what to do for us. We have a -t, and what -t means is that tags the image that we're building. So it's easily defined. You might get some random name if you don't use the tag. So I use tag, and I'm saying my microservice, and I could call this anything as long as I remember what it is. And then I'm going to pass a context, like where is my Docker file? Where do I get my instruction? So I hit the dot. I'm actually in the same folder where my Docker file is, so I'm going to pass dot. If I had it someplace else, you can say -f and give it the location. But it has to be below where you're at. It can't be above. So kind of remember that for getting errors.
So it's a child within a parent folder.
Yeah, you can't go up to above you, right? You can't go to another parent to call it.
Got it.
So something. Oh, goodness gracious. Okay, hang on a second. So what we have here is we have a Unicode character somewhere.
Did you save your file?
Yes, James, I saved my file. I didn't save my file. Thank you. I ran into an issue. We're just going to say contact the producer instead of that. So, all right, let's try that again. Oh, get the same problem. All right. Here. I'm in the right place. Our Docker file. Yeah, we have save all. Really weird. Build definition. I'm going to yeah, we've got some Unicode characters here somewhere.
We have some suggestions. Try reformatting the file.
Yeah, this is a it's there. This is maybe a line endings problem. Give me 1 second here.
First line from has an invalid char.
Yeah, but it doesn't. That's the thing, is that
it lies.
It lies. Lies. All right, let's do this. I'm going to do cheat here.
Next month's episode, cheating while presenting.
Okay. So let's see if this works. So I did basically use the Docker tool in order to generate our Docker file. It has the same instructions here. So now let's do a Docker build here. There we go, magic.
Woohoo!
To check that copy.
Look at it go.
Over there, I think the copy might be getting us some funky characters there. So what this is doing is it's actually downloading the necessary items that we need that I don't have on my current machine. So I might not have the base image that I need locally. So it's bringing that down, and then also doing all the dependencies that exist in there as well. And then it'll actually execute the instructions that are there and then create my image. And you'll see right here, it's been writing the image. There's your funky name that you might get. And then it names it to something specific, right? So I clear. And what we have to do next is we can look at Docker images. Now, Docker images is just a command. Again, it's going to list all of the images that exist on my machine. And I'm going to widen this just a little bit so we can kind of see what's going on there. And let's find, there's my microservice. You see it was built 33 seconds ago, and it's got a file size of 209 megs. I'm sure there's some things that we could thin out of that to make it a little bit smaller. You'll see that I've got some other ones on here that are much smaller, 86 megs as well, right? So there's our container that we just created. And now we have this, my microservice, which is all well and fine, that we've got it packaged up in an image, but now how do we actually run it? And I think that's our next step here. Now, you remember that when we first ran the app, after I figured out what the right URL was, it was running on my port 5000 on my current machine. And now what we're going to do is actually run the application in the container itself. So if I did the commands that we have here, and we'll actually copy this and paste it. Hopefully we don't get a bad thing. You'll see we got Docker run IT RM. Now this means I'm running it interactive, and I'm going to stream my terminal, the terminal output from the container onto my screen. The -- RM, which will basically says remove the container from the running state once we exit the app itself. -P will specify the ports, and remember always that the left side of it is the outside port, the port you're actually going to run, and then port 80 is the port that is being exposed by the Docker container. And you'll see it says expose 80. We expose port 80 by default. This is really not a necessary statement in this particular case, but that's the port that we want to run. If you're running something that has Redis or some other type of a platform that has a specific port to run on, you may or may not see that port specified. So that's how you want to make sure you expose that. The next thing I'm going to do is actually name the container. This is helpful. You'll see in a second when we see what's running to find what's running. And then I'm going to pass the name of the image that we just created, which is my microservice. And you'll see that it's running, right? It was super fast, actually faster than it was on my own machine. And now if I go to the localhost 3000, where we're expecting to run that, because that's where we said to run, you'll see that we're getting the same results. And now it's inside of a container. It's not running on my actual machine, running inside of a container. If I bring up the Docker tools, the Docker dashboard here, I'll drag this up here. Oh, sorry, that's not what we want. So this is the Docker dashboard. You can see it's got my microservice container. This is what we just ran, and it's running on port 3000. And you can see the same terminal exposed here that we saw where we ran it from and where you might run it from. We can also inspect and see the URLs that are there, that is actually running in a container, and what .NET versions and things like that are running it on. So this is a super great tool for looking at things like stats. You can see that the memory usage of that container, CPU, et cetera, and that's only within that specific container. So all of those isolated usage within that one thing. All right.
Wow, that's super useful.
So if it wants me to do a Docker PS, yes, let me add another terminal here. And what I just showed you inside of the Docker tools is very similar as if I did Docker PS. And that gives me the running, actually, that. I'm going to pass the -A. Those are all of my running containers. And we should have one of our other containers in here running if I didn't shut it down. There it is. My microservice says the port that's running on there is 3000. It's wrapping a little bit, sorry. And you say that it has that arrow to 80, what the name of it is, and how long it's really been up. So it's been up about a minute or so. Right? And that gives us that information. So Control C out of that. Leave that container. All right. At that point, now we have actually created our container, our kind of deployable item that we can put into Kubernetes or app service and things like that. This is the independent service that only gives us the weather. So this is a very specific thing. It has no dependencies on anything else, but also allows you to continually iterate on this one particular project. All right. I think if I hit continue, we would be on to the next thing. So
so we've reached the edge of our first workshop. Let's take a couple moments here to answer some questions. We have some really great questions in the chat.
Yeah.
Really quick though, can you maybe walk through the steps of how you generated the Docker file from VS Code? I just want to make sure that it's really clear for folks.
Definitely I can do that.
And also, I did find the bug here. This is my fault. Producer's fault. The echo dot adds that invalid character. So if you just create that file manually in VS Code and then copy it, it'll work just fine. I'm
all right.
Doing a PR now. Doing it live.
Doing it live. Okay, so how did I actually generate the Docker file, right? And that's a good question. And that speaks to the tooling that exists and available to VS Code and Visual Studio. We have this Docker extension, and if I just go in VS Code, go to my thing here, and I say, let me look for Docker. I can choose that here. And I just install this here. It gives me the ability to kind of manage my containers, do a lot of the terminal stuff I was doing, all within VS Code's kind of environment. Now, how did I generate the actual file? I first pulled up the command palette, and I do that on Windows by doing Control-Shift-P. On a Mac, it's Command-Shift-P. And you'll see that if I type Docker, here's all of the things that I can do related to Docker in my application. And I just said, hey, add Docker files to my workspace. It's going to ask me, what platform am I using? We're using ASP.NET Core in this particular instance. What operating system do I want to be my base operating system? I chose Linux because the images are very, very small, and I'm going to be deploying it to a Linux-based host. And then it asked me, what ports is your app listening on? Now, as I mentioned, you might have port-specific apps that you're putting inside of your container, so you need to make sure you expose the correct ports. We expose 80 by default. This one also gives you the option for the security port of 443. So I would just choose 80. And then when I hit enter, it says, do I want to include compose files? That's an advanced one. That's if I'm doing multiple services together that I want to deploy and manage together. I'm not doing that. I'm doing a single one. And we already exist, so we're not going to say, no, don't overwrite my stuff. And that's how it generates this. In Visual Studio, there's also the Docker tools for Visual Studio, where you can just right-click your project folder and say add container support, and it walks through a very similar prompt. In fact, the video that was in the intro, I walked through that as an example on how to do it with Visual Studio.
Excellent. Thank you for walking through that. It's much more clear to me now. A few more questions that we have.
Yeah.
What are the best resources to create Docker images for legacy .NET applications?
Okay, so yeah, so non-core, probably 4.7 and lower. Those have to run on Windows. They have a Windows dependency. So there are Docker containers Docker images specific to Windows as well. So instead of having this from statement that I have up here, it would vary in order to make sure we're building for Windows. I believe the tag is the same. It just knows when it gets built it's for Windows instead of Linux. So yeah, there are Windows-based .NET images that are available. I actually talking about older applications, I have an example. If you just search on my GitHub for Nerd Dinner, and if you're familiar with Nerd Dinner, that's like 13 years old or something. I actually put that in a Docker container without any code changes and was able to deploy that to app service. So that was a lot of fun. Nerd Dinner was actually created before GitHub even existed. So I had to pull that from our old repository source that I forget the name of.
Oh, wow. I actually didn't know that it was that old.
Mm-hmm.
What VS Code extensions are you using for this?
I'm not using anything specific for this other than the Docker one that I just spoke to. Yeah, if I look at my installed ones, I have a lot of things, right? And I've got a lot of fun things. Some Azure-related things for deploying to Azure, databases, Kubernetes.
Ooh, those might be useful later.
Yeah, there's a lot of extensions that are out there that will be based on the type of application you're writing it in, frameworks. There's a lot of fun things. There's like millions of these things. It's ridiculous. So if you need an extension for helping, it's probably out there.
It's already in the library.
Yeah.
Okay, let's take maybe one more question before we move on. So let's see. Can you explain a little bit about the authentication over microservices and API gateway?
Yeah, so that's a good question. Typically, you wouldn't. The facade or API gateway that I spoke to in the quick presentation. That's typically where you're going to do all of your authentication, right? So that's your entry point to your larger app. And there's support obviously for. Don't think of there's anything special as it relates to containers in how your applications exchange information. If you're passing JOT tokens or using Active Directory, all those capabilities still exist. The recommendation that I would have is if you're deploying things to Azure and doing a facade layer like API management has those kind of authentication capabilities available to you. But what I would do, and this is my opinion, is if I'm building a facade that exposes all of my individual services underneath. I'm going to terminate my authentication there. And then basically the talking that goes between all of the services that exist inside of the container architecture like Kubernetes, those are all secure and they can kind of talk to each other without having any kind of boundary issues. Oh, you're muted. I got to say it.
There's no recording that goes forth without someone doing that. So all of those are available,
Yes.
just like within the library.
Yeah, exactly.
Okay.
Exactly.
Okay. So we will save time for more questions. Keep them coming. We will take time at the end as well to kind of really focus on all questions related to microservices. So next up, we have our next workshop, which we're actually going to deploy to Azure.
Yeah, look at that. Deploy to Azure.
That's exciting.
Okay. Yeah. So if I hit this button here, now also when you get to the bottom of these tutorials, there's a lot of just resources of things that you would be interested in. There's a link to all the learn resources for microservices, and also those docs and ebooks. So be sure to do that. So as Jamie mentioned, we're going to jump into the Azure space and start deploying our application. That's right, to the cloud. To the cloud.
Yeah, and just for everybody who's joined us more recently, all of the resources for this event can be found on the homepage, as well as if you go to aka.ms/microservices_resources. All of the links for this event are in there, as well as a bunch more. And for those learn modules that were linked below, we highly suggest that you do that because we're doing a learn challenge right now where you get points for completing your learn modules, and that's exciting.
Mm-hmm.
So yeah, I think I believe the link for the next workshop will be posted in the chat shortly and posted up here shortly. But yeah, so we're going to move on to deploying a microservice to Azure. This is exciting.
So if you don't get to the link, just remember at the very bottom of that first one, you just click on that button and it'll actually take you to the next thing.
Perfect.
All right. So now that we have our microservice in a container and that image has been built for us, the next step obviously is to put it somewhere where it can run in production. It's nice that we can run it on our machine and everything's fancy and no problems, but we need to actually put it somewhere for production. And the first thing that we're going to do is push this to a Docker Hub repository. Now, Docker Hub is an image or container repository, much like GitHub is a repository for your code. We also have Azure Container Registry, which is the same thing, but can be also private. Just like your code repositories, there's public and private resources there. We're using Docker Hub in this instance because it's free, and we can just continue to move on without me putting it down a credit card somewhere.
Great.
So the first thing we want to do is actually
quick question, actually,
yeah.
Shane. Do they need an Azure subscription for this?
For this one, we do. Actually, let's look at the.
Because I was saying we can point everybody to the free Azure subscription that they can download.
Hang on.
So that they can.
Yeah, actually, I think it tells us when we get to the setup Azure tools.
Okay, great. I just want to make sure that no worries. We're not going to charge anybody for Azure. It is free and available. Yeah.
All right. In this particular case, yes. So the first thing we're going to do is you can create a Docker Hub account. Again, it's much like a code repository account. I happen to have one. So the first thing I want to do is actually log into my account. Oh, clear. Shane can't type. Pull this up and we'll just say Docker login. So I have my credentials saved and super secret on my machine, so it automatically does it, but you could be prompted for username and password. That's there. Now that we're logged in, I can actually now tag my image with my Docker username and the repository of where I want it to be pushed. Right. In this particular case, is my microservice. So we'll just do. Let me copy that first one. So it's more than I want to type. And my username, again, think of code repository, same idea. And hit enter. So now what that's done is it tagged the My Microservice image with this SP Boyer / My Microservice. Your tag has to correlate one-to-one with where we're pushing it in Docker Hub. If I had it named something different, I just want to, when I push it, I want to make sure that it matches where I'm pushing it. So now I'm going to do Docker push. And I'm going to push it to my organization / where I want it to go. And what's neat about this is we're only pushing our parts of the application because these are all built-in layers. You'll see that we have different entries here. These are the individual layers of the image themselves. So it's pushing everything there. If I decided to change my application and hit push again, there may or may not be layers here that say from cache, which means that that layer already exists there. There's no need for us to take that additional hit for us to push it up. And I'm sure there were some cache pieces here because I think this is right around 270 megs. And that would take a little bit more time than most, depending on your connectivity. So now I've pushed my image there. And if I actually went to Docker Hub, which is hub.docker.com, and we signed in here. Thank you for not doxing me. All right, awesome. So we can go back and share my screen again. You'll see that there's the My Microservice. I just updated that. And it gives us all the information about it. What's the tag? This is the latest one, and you can tag it with other versions. So I could put like a colon at the end of the name of my tag, and then put like 2.5 or whatever it is. You'll see just like this, right? You'll see the tags here. And I think in our other one, you'll see that the image is the compressed size there. If I go back to the Docker Hub. Oh, great. Hang on. Wrong one. Let's just go back here.
Whoops.
There we go. That's what I was trying to get to. You'll see that I've got some images here, and it shows you how many times they've actually been pulled. This / backend, I think, is the backend to Nerd Dinner. It's been pulled over 50,000 times. So let's go back to our instructions here. Now we've got it there. I went up and validated that it exists. The other thing you can do is if you do the Docker images and look for microservice. Oh, sorry, wrong command, wrong OS. If I scroll up, you'll see that we have this here. One thing I'll explain is you'll see it says 209 here, 209 here. These are actually the same exact image. It's not an actual copy of the other one. So this is not 418. It's actually still 209 when you do tags like that. There's just a little bit of metadata there. All right. So I hit continue. And now we're getting into our free account and installing the Azure CLI. So creating a free account, literally if you go to azure.microsoft.com/free, you can get your free account there. If you already have an account, you can just skip right past it. And then the other thing is the Azure CLI. And now the Azure CLI allows us to interact with the Azure resources and push and pull and view and see all the things that we have within Azure for you deploying your applications. I'm already logged in, so actually I should probably just make sure I'm already logged in. You'll see that it pops the browser, passes some tokens, and you've logged in, and now it's going to actually run an account. access here. So let's get out of this. And I don't know why it just swaps to that one. So I have the Azure CLI logged in because I did the AZ login. The next thing that we want to do is actually install the Kubernetes service CLI, or the Kubernetes CLI. You can run this command and will actually bring down the resources that you need in order to install the Kubernetes stuff. And that would give you the Kubernetes CLI capabilities as well, which we're going to need in order to do some work to deploy this.
And did you already have the CLI installed on your machine?
I do, yeah.
Okay.
I have all of the things for this. As with Docker, there are Azure extensions. There's Kubernetes extensions as well in VS Code if that's the editor of your choice. So what I'm going to do now is start creating those Azure resources. Now, this is going to be a step-by-step thing. If your company or location actually uses things like Azure DevOps or GitHub Actions, there are tools in order to do this in one fell swoop. But this will give you an understanding of how things are organized when it comes to our app. So the first thing I want to make sure I don't have this already defined. It's very possible. I'm looking for my microservices. And look at that. I did that already. Awesome. So I've already completed this step here. So we're going to do the AZ group create -name, which names our resources. Now our resource group is what we're creating here. This is kind of a logical way to group your items in your resources within Azure. This could be a project name or even a location name, depending on how you're operating. And then the location here defines what Azure region do we want to actually deploy our resources to. In this case, it chooses West US. So you may or may not have all of the resources, locations available to you, depending on kind of where your Azure account lies. If you're in Europe or in certain sectors, like government sector, et cetera. So you can look at this particular command here, list locations. And I passed the out table because this gives me a kind of a human readable format. By default, it's JSON that comes out. So that's why we pass the output type of table. So you'll see all of the things that I have access to based on my subscription. And we can do any of the names is what we want to pass here. So depending on where you're at, you want to make sure you're deploying your app to the region that is closest to your customer. If you're scaling and getting into multiple instances of, you might have multiple regions that you're deploying your app to, and then using some load balancing or other service that we provide to get the global traffic manager is the right one. All right. I have a bunch of subscriptions, which I'm not going to put up on the screen just for security's sake, but you can see the account lists that you have access to by doing the list and --all. That'll give you your subscriptions list. And then you want to make sure of the subscriptions that you see, this is how you set your default subscription that you're going to be using for this particular resource. And just a note to the producer, we should probably do this before we do this. You should set your account.
I think it says it's optional. That's great feedback for the producer.
Yeah. The man behind the curtain. So the next thing we're going to do is I'm actually going to create a Kubernetes cluster. And what this allows me to do is specify the resources where I'm going to be deploying my application. We want it to be on Kubernetes. It gives me all the scalability and tracing and all the wonderful things that are associated with microservice development architecture. So let me copy this and I'll put it on the screen so we can walk through it a little bit. We're calling AKS, which is our Kubernetes service, which we installed the tooling for earlier. We're going to call create and then pass a resource group that we just passed, that we just created, the My Microservices resources. Now, you might want to name yours something different because there is some one case only type of situations depending on the service. I'm going to give it a name. That sounds like a pretty good name. I'm actually going to name this probably something different. Oh, go here, go back to this. This is just in case somebody already created this. And I'm also going to copy that.
It is now Shane's cluster.
Right, for learn. The node count is the number of VMs that we're allocating. We're only doing one right now for this particular thing. And we're also going to enable this particular option, this HTTP application routing, which allows us to expose our services to the internet and also have them talk to each other via DNS, etc. And then the generate SSH keys gives us the ability to have access to the VMs from our local machine. So this may take a moment or so to create this. While this is happening, let's jump to some questions.
Yeah, definitely. Because we have a few. Let's see. Does Docker need Windows Pro version, or can you use it on Linux?
You can use it on Linux. You can use it on Windows. If you go to the Docker for Desktop site, when you go to download, I believe it specifies which versions of Windows it supports. I don't know off the top of my head.
Okay, so but it is supported at least by the normal Windows version and Linux.
Mm-hmm. And also Mac as well.
Right. Another question we have. What if my company doesn't want me to push public or necessarily publish to Docker? Are there other registries for this?
Yes, there is. So Azure Container Registry is one that we obviously is a service that we provide in Azure. And that's where a lot of companies are really pushing their stuff because that is private. You can set up the tunnels between Azure and your on-prem resources. So that's really great to have that particular option. GitHub also supports hosting that type of registry resource. So you can look at that too, and that can be also public or private.
Okay, great. So we have that option.
I'll just let you know what I'm running through here. I tried to deploy that cluster into my West US resources, and it's not allowed to. I'm not allowed to have that in my West US, probably because I've maxed out what's there. So I'm just going to go to a different location.
We'll just relocate.
Right.
So you're going to run that script again, just
I just created a new resource group, and I just have to change that here.
Okay.
But you can ask another question. Fine.
Okay. Would it make sense to have a microservice architecture without containers?
That's kind of an oxymoron by definition, meaning that microservices architecture, as it's defined, are containers like images, application pieces, deployable and scalable, containers. Now, the idea of having services that are independently deployable and have no dependencies would be like what's it called, SOA architecture, right? So they're all managed independently. But the challenge I see with that is I can't, although they are not dependent upon each other, they are all related services, and putting in something like containers in Kubernetes allows you to manage all those resources instead of a single entity. So I would say no, because it just defies the actual definition of microservice architecture.
I see. That makes sense to me. If we ran multiple instances, would they use the same port number or different port numbers?
They would use actually the same port number, because what happens in Kubernetes is that the individual images get deployed on what's known as pods. And when somebody asks for like my service, it actually will automatically do the balancing amongst all the pods as it scales up and out. So you would still expose port 80 because it's a web service in this particular case, and that's the web port we're going to communicate on. If I was
so
running, sorry, if I was just going to add one thing, if you're running multiple containers on your machine, obviously the only port that you can access it is a single port. So when earlier in the example where we did a 3000:80, I could do another port 3001:80 and run another container, and that still gives me the capability of running both of them kind of on the same port inside, but externally there had to be access through different ports.
I see. Okay. We're still running it. Okay. We still have. Let's see. If we are doing on-premise for deployment, should and/or can we do microservices?
Hang on a second. What was that? Sorry.
If we are doing on-premise for deployment, should or can we do use microservices?
Yeah, should is one of those things like, that's saying that you should always use containers and microservices. It depends on the architecture of your app. Like they're not necessary for you to be productive and create productive applications. But if you want the scalability and velocity that architecture provides, then yes, definitely do microservice type containers. And yes, you can deploy on-prem, provided that you have the application host framework set up properly, like Kubernetes. You can run Kubernetes locally on your own own servers. I would recommend maybe putting it in a cloud and doing some tunneling just because they can manage it instead of you. But yeah, you could do it on-prem for sure.
Okay, good to know. Oh, we're still running. So
this might take some time. More questions.
More questions. Okay, we have more, so we'll keep going. Okay. Stephen asks, is it a bad idea to put your database or data store in the same container as your app?
I have been waiting for this question because I knew somebody was going to ask it. So you wouldn't put it in your same container, right? Because if you're doing it in your same container, then it's actually part of your app. So that might be something like, I've seen even my own applications years ago where I might have some sort of a DB file or some sort of DB that can run inside of my own application. A related question to this is, should I put my database in a container? And the reason really you don't want to put your database in a container is, remember, these containers are immutable, which means that they should be able to die and come back to life without you losing any information or experience. When you put your database in the container, the data files that are associated with that, if they are also in that container, when it gets destroyed or scaled or what have you, because there's auto recovery built into Kubernetes and such, that data will also go away. Now, a solution to that is, can I put my database in my container, but my files that it uses outside? And that's yes. And you would basically volume map your data files to some other store, like it might be Azure Storage or Azure Files or something like that. And then when I run my container, there's a command when you run it to say volume mount XYZ to XYZ. And that's how you would get those together. That makes sense. You're muted again. It's twice.
Twice. I don't want to hear people tapping. Okay. It looks like we did. It worked though. We got the runs to build.
Yes.
Amazing.
In fact, I was running another command to kind of see what status we're in. If you run this AZ aka list, it'll give you all of your Kubernetes services and gives you the the status of where they're at. And it just so happens it was succeeded when I went to go check. It's like, I know you're going to check on me, so I'm going to be done.
It knew.
All right, so now it's there, and we have our cluster is ready to go, and now we have to create a deployment, create deployment instructions in order to push our container and run it there. So I want to make sure we are in the microservice area, yeah, and then I'm not going to copy and paste that instruction. We are just going to create a new file.
I think that the YAML file will work fine. The issue is that when you do echo dot with PowerShell, it actually puts the wrong encoding on it, not with a command prompt, which is what I tested it on appropriately.
Oh, yeah.
So that was the issue there, and we're fixing the docs just to say create the file manually. So that was the issue. That was fun. We got a PR in and on the way. So I guess
we are fixing things in real time.
Yeah.
This is amazing.
All right, so now I have my deploy.yaml file. And I'm going to copy the instructions here, and we'll go through what these are. Let me close all this stuff up here. All right, so we have, this is really, again, a set of instructions on how to deploy this to Kubernetes. So we're basically telling what type of it is. This is a deployment instruction. We're giving it a name. How many replicas, like how many instances of this do we want running? Right now, we're just going to do one. We're adding some metadata around labels and such. The spec is the important thing here because I need to define what containers am I deploying and how do they run. So again, what's the name of it? The image is where we're getting our image from. Remember, we just pushed that to Docker Hub. And by default, this is going to look at Docker Hub unless you specify some other endpoints, like Azure has, like I think it's called mcr.az something.io. So your image is actually the full URL of your name. If I went over to Docker Hub and looked at this here, it should tell me how to pull it. But yeah, I would pull it with this right here, my microservice. Now, it's automatically going to default to latest, but if you have a different version, you can put that there. We need to specify what ports we're going to be running this image on. So we tell the container port's 80, and then we're going to set some environment variables again, and that's defining that the ASP.NET Core URLs is also 80. We have to give it some a selector, so when the actual control plane of Kubernetes is looking for the service by name, it kind of looks like there. The 3 dashes here indicates that we're going to create more instructions of a different type. This could also just be a different file from here down. So we're not going to make 2 files, just make it 1. So we have a service. What's the name of the service that relates to these pieces up here? So if something goes wrong, make sure your names are correct and spelled correctly. We're specifying a load balancer. This is basically an infrastructure piece that allows us to run multiple instances of this. So if I had replicas of 15 here, it knows how to balance that. So that answers that question before about ports. And then again, adding a selector of my microservice. Let me go back to our instructions. So now we're actually going to run the deployment. Let me make sure I save this file. Here it is. And what we're doing here is we're using the Kubernetes CLI. People will debate if it's kubectl, kubectl, kube something. I usually alias mine as K. It's a lot easier to type. And then I say apply, which means we're going to apply the file, and we define the file that we just created up here. So if all goes well, it's been created. That was super fast. Now, what this does is this actually pulls the image from Docker Hub to my Kubernetes cluster when it gets created. So it's created deployment, and it's created the microservice service as well. So we can actually see what's going on here. And we've got our load balancer that we're looking for the service here, and we're waiting for an external IP to be allocated for us. Right now, This is the internal IP, and then the external IP is what happens here. So,
and will the external IP be automatically synced once it finds one?
Yes. Okay. You'll get another line that'll pop down and say, hey, that's been done. This -- watch basically says we're waiting for this thing to be implemented. And how much time does it take? Don't know. Sometimes I've had it happen within a minute or so. Sometimes it's been a little bit longer. And we'll just wait for that to come up. So while we're doing that, let's answer some more questions if we have them.
Yay. Okay. So we do have more questions.
Good.
Keep the questions coming in. We will have a Q&A at the end as well. Will all versions of the container exist on the server?
All versions of the container image will exist in your repositories in Docker Hub, in Azure Container Registry, things like that. When you're actually creating the app itself, you can have multiple versions. Sorry, only the version that's running will exist on the cluster. So depending on what you've defined for your service, will determine what's running there. On your local machine is where you're creating all of these images, and you'll have however many you create. And same with the repositories for the container images themselves. However many you push there is however many it'll host. It'll only run one version at a time. And if it scales, it runs the same version across them.
I see. So one version, but it's multiple containers.
Right.
Depending on where you push it. Okay.
Mm-hmm.
So how do microservices relate to domain-driven design?
Yeah, domain-driven design is another architectural style. You could still put all of your services around those business operations and make them individually. I would say that the DDD resources for containers, I would have to look up to get more information on how to kind of put those things together. But you can still certainly deploy your application in containers regardless of how it's architected from a programming perspective.
Okay. Yeah, I was like, it's still waiting. Okay. Tung asks, how do microservices communicate with each other?
Yeah, this may have been asked or covered before. So if I have multiple microservices that are dependent upon each other, so I might have a worker service that's just doing work, like taking things off of a queue, and there may be some, like, I don't know, status endpoint. If you're running inside the cluster, the microservices themselves can be, again, just through a URL call, HTTP call, and they're called by name. So this one here is called My Microservice. So the endpoint within the cluster would be, HTTP / My Microservices / endpoint, where typically you're having to manage all those URLs in when you're deploying things. It's all resolution by name. You can also use gRPC, which is just a different protocol. It's faster, it's binary. If you're doing service-to-service communication inside the cluster, that's the best way to do that. Externally to apps, it's more common, at least for now, to use HTTP type calls, REST, or things like that. All right, let me see.
Yeah, it's like, how are we doing?
Still waiting.
Okay. So are there other types of containers other than Docker? I think you mentioned this earlier, but.
Yeah, there's some other ways to create them, and one other popular one, the name escapes me now. The only ones that I've used, quite honestly, are the ones that I create using Docker. But there are other ways to generate the actual image file. The most common way to do is with the Docker tooling.
Is with the Docker tooling. Okay, that makes sense. Yeah, it's like you're the Docker king. Next programmer asks, in AKS or Docker, where should I put my SSL certificates and handle auto renewal?
That question I'd have to look up, to be honest. I'd have to look at their resources. I know we have Azure Docs on SSL certs to manage those within your cluster and things. That's kind of above and beyond of what we're doing here. But yeah, we definitely have some Azure resources around AKS and SSL certs that we can probably share as we get closer to the end. I will look that up in the meantime.
Yeah, it's like we can actually look that up and link that later.
Yeah, for sure. I saw a question come through earlier and asked the question, how small should microservices be? And there's a little bit of a play on words. We talked about it earlier on. It depends on what your measuring stick is, right? Is it the virtual size of your application? Is it the size on disk? Is it the number of classes or endpoints or things like that? It depends on how you're measuring your service. If your service, it can be as big or as small as you want from a coding size, provided that it is isolated to a single, business operation. Is kind of the practices that are put forth of, again, I might be only doing a service that's for orders. Now my order service might be very large and very involved, but it's only specific to the order service, where I could have a customer service, which is, very small and specific again to the customers. So there's no disk size requirement. I would say if you are getting in an app and you feel like this is a little big, you might have some issues around scaling, because the image that you create, the container image that you create, is what gets replicated. So if you have a humongous one, and I have no idea what that number is, but if you have some scaling lag, you might want to look at breaking up your application into some smaller pieces. See where we're at, Jamie. We're still pending. We're at the mercy of waiting for this, and this could be partially my fault for all the resources that I have going on there.
Oh, the fun of deployment.
Yeah. But the thing is once it is deployed, right? Once it actually is deployed, then managing it is fine. Now, actually, this is already deployed there. We're just waiting for an allocation of the IP.
And do you have to wait for that IP allocation before proceeding?
Yeah, so I think that in order to show the application running in Azure through a public IP, this is the best way to do it. There is a way to forward this particular port to my machine, and I cannot recall the command to do that. So we are going to have to be patient, it looks like. Let's see what the rest.
Yeah, what does our PowerShell say?
Oh. Yeah, we're still pending at this point.
Okay. Well, we do have a couple more questions. Actually, we have a lot of questions around databases, like how do we connect? Do I need multiple databases? Can you just elaborate a little bit more about those?
Yeah. So there's a lot of scenarios when it comes to developing apps. I think with databases and containers, I have an example on my blog, and we've done it at a couple of build and ignite things where I have a subset of my data inside of a container. So the data and the engine all exist inside the container for local development, right? So I might want to work on a specific piece. I only have a subset of my actual data or some test data in a container, and that allows me to run things like SQL Server or MongoDB or something like that locally on my machine without actually having to install those things on the machine itself, because they're all inside the container. If anybody's tried to install SQL Server on our local machine, it takes some time to do. But we have SQL Server now available in a Linux container that allows you to run your ASP.NET Core apps and connect to that as if it was another server running anywhere, quite honestly. That's a really good practice for working with databases in containers, so just using it for local development. If you're going to run a container, I don't suggest running a database in a container. There are so many services available that do all the hard work for you. Things like Azure SQL and Cosmos DB. You can run those inside of a container. There's really no reason to, because that's a service that's provided by a vendor, us or somebody else, that they do the management of the database engine and updates and security and all those things. Keep in mind that the container that you create is almost like taking a picture of where your app is in that one point in time. I could actually pull down a container using .NET Core 1.0 and do Docker run on it, and it's still going to work just fine because all of my resources are combined in there. I'm not relying on any other thing, and the same is with the databases as well.
Okay. Kind of imagine that like when you're playing a game and you make it to save.
Yes. No, that's exactly right. No, that's exactly right. That's a good one. Like I want to pick it up and keep going, or pick it up and see where I was. You can do that too.
Amazing. You still pending here?
Still pending.
Okay.
Let's see here. Still waiting. What other questions have we got here?
Yeah, I was going to say that's okay. We still have some questions. How do we handle version numbers with microservices?
Oh, good question. Let's open up another window here while we're waiting for that stuff to happen. You don't do it by typing wrong. That's one thing you don't do. Oh, my goodness. There we go. All right. So remember we did Docker build and we passed this tag number. I think originally it was like my microservice. And then we pass the context where the Docker file exists. I can actually do a colon here and add a version of my image here. When I talked earlier about rolling back deployments, so let's say this is 1.0. So when I build that, it's building my application with that particular tag. So we're waiting for things to finish up here. Waiting. And now I'll have a 1.0 tag in addition to the colon latest tag. So you'll see that if I go all the way to the bottom here, and microservices 1.0. So if I did Docker push, let's see if we can find that command here, where we do the Docker push. A few steps. So now when I do the Docker push, I can say colon 1.0. Oh, I don't have that. Now it's going to push those tags of latest and also of the 1.0. Now, what happens is when you do the deployments, they do a Docker pull, right? That pulls the image down. And when you specify in your deployment files the image to be pulled, I would just change this to 1.0. Now I have a different version there. If something went bad in my deployment, I could just change this back to latest and reapply this particular file, and it's going to back out the quote unquote bad image and then put in something new. So that's how you manage your actual versions. It's very similar to the Docker files here, where we have how we tag our image, right? We have version 5, and there's 3.7, there's 4.01, there's all these different versions that we have up here, and that's how we manage the different versions. Does that make sense?
I was on mute. Yes. Yes. Oh, am I echoing to you?
No, I don't think so.
Okay, good. I have a few more questions. Clever Compiler from Twitch were you thinking of Podman as the Docker alternative potentially?
That's possible. Yeah, there's a bunch of variations of tools and things out there that that you can use again to build and manage those things. So yeah, it's possible.
Okay. So Lynn asks, how would you create a front end as a microservice and deploy it? And is that even recommended?
Yeah, that's a very common question as well, is that I don't know, that's a good question. How would I say that? So if I look at front ends, let's say like it's a Blazor app or maybe Angular or Vue or something like that. What you have to ask yourself is, what is it that you're scaling? And in the world of single page applications, all of the work is done on the client. So once it's down on the browser, you can do what you need to do unless you're making API calls. Now, those API calls should be calling microservices type of stuff, but you're not. If you say scale my application, you really need to scale the front end. Now, if it's something like some server-based technology, maybe it's like, to use a bad example, classic ASP, right? Classic ASP, everything was built on the server and rendered down. So that might be something where you have to scale your application. Most of the front ends right now, between Blazor and the other static web app type of front ends, I don't really see a need for it to be in a container. But as a group of deployment resources, it's still okay to do it. Just know that you're never going to scale that one particular container.
Yeah, because I guess that the front end isn't as much the scale as much as the back end for the data.
Right, exactly. I'm going to try and see if I can get our port for us.
Yeah, because we're so close. We just need to scale. Oh, the issues with scaling.
My microservice, is that what it was? Yeah. And let's see if this will work. And I apologize for the lawnmowers because apparently they decided to show up early today. Happen to hear those. 80. That works.
It's doing something.
Waiting.
I was like, I have one more question for you.
Yeah, no, please do.
While we wait, okay. In AKS, next programmer asks, in AKS, how do we set up different environments for dev, QA, pre-production, etc.?
You have multiple AKS instances. Simple enough. Now, the total, like when we did our first creation and we said node count was 1, that might be more for production than it is for dev or QA or something like that. Obviously, we want to keep them as equal as possible, but you would definitely set up different actual environments or instances of your AKS cluster for each one of those environments.
Okay, so they would need to be different.
Yeah. All right, let's see if we're anywhere closer to where we need to be. Sigh. All right, we're stuck here. All right, what I'm going to do here, let me just do this because we can walk through the rest here.
Okay.
So once it's deployed and we're able to browse to that IP that we're waiting on, and let's say we want to scale it. The big weekend coming up, we want to make sure we have proper resources, what have you. I'm going to call, use the Kubernetes CLI, I'll call scale, say how many replicas I want, and then define the actual deployment. So if I go back to our deploy YAML file here, you'll see that our initial replicas was 1. And that can scale us to 2 or 20 or what have you. And that gives us our scalability. Now, there's some automation available on the platforms that allow you to say, based on CPU, based on overall resources or RAM or things like that, there's these triggers that you can do to help scale your applications up and down based on those triggers as well. But this is how you would manually do the My Microservice. I'll look at it with scaled. So if I look at cube, CTL, get all, you'll see here, now I've got 2 waiting to be allocated because we're waiting on our IP right now. And I could scale it to 20 or 100 or what have you. It's all based on the needs. And the load balancing of those services are all managed by Kubernetes in a control plane. So I think if we did kube, GPL, and git pods. We're still waiting for that to happen. All right.
Okay.
So we'll hit continue for scaling. And then this is a very important step. If you're working through these tutorials and you're creating all these resources, please make sure that you clean up after yourself when you're done, as to not get unrecognizable charges. So if I wanted to actually delete things here, I would say AZ group delete that one in the actual name of your resource group that we created. That's why it's important to do resource groups and put things in a resource group that are related. There's goods and bads. If you delete the resource group, everything that's in it also gets deleted. So this would be inclusive of our cluster, of any special things like API management tools or monitoring tools that we put in that side of the resource group. It will actually be deleted. So I'll make sure I clean it back to myself after I verify things. It's not where I want it to go. And that's the end of that particular thing for Kubernetes in deploying the app. I'm sorry, we're still waiting on our IP. I'll have to ping support about that and see what's going on there.
We did have a few people in the chat that have been following along at home and did say that they have deployed and they got an IP before you. So
that's crazy.
Yay.
They're probably trying to hit my credit card or something, and I've run out of allocated account resources. Okay, perfect. Do we have any more questions? How are we doing on the agenda here?
Yeah, so we have a few more questions. I'll definitely take a few more. Okay. And then we'll close up here in about 10 minutes.
Okay.
Congratulations, everybody who is able to deploy your app to Azure. We apologize for the delay here.
Except for me.
Except for you. No claps for shame. But congratulations, everybody else. You're amazing. You're awesome. You're so smart. I will feel free to send in your questions and we'll answer those as they come in. So Rothwell asks, can you talk about authentication and microservice?
Yeah, I think maybe they joined a little bit different or missed the
yeah, this is in the
topic earlier. Yeah, it's very interesting when it comes to authentication because I think typically we all think when we're creating a service, we have to secure it. So we're going to run on SSL, or we might need tokens, right, for that. When you're doing authentication from an external app into your microservice architecture, those same semantics should be followed, right? You can use Active Directory or social accounts or all of the authentication ways you can do Active Directory, et cetera. But that, in my opinion, should be done at the API management level or your aggregator service letter. Like, what is the entry point to the rest of your architecture? Everything underneath runs kind of not in a sandbox is probably a bad term, but it runs all contained by itself, like inside of a fence. So those can all talk HTTP without any SSL overhead, unless you have to pass like tokens down further. But the same semantics of authentication between your services should still be practiced. And if you're using something like API management, there are tools built into APIM for things like Active Directory authentication, for example, that helps you manage that too. Okay. I see a question here. You're muted again. All right. So the next question I'll bring up, it looks like Steven mentioned, can I talk a little bit about Service Fabric and if it's something I would use instead of Docker? I can't speak specifically to Service Fabric. As I understand Service Fabric, there's a lot of actor models as well. But there's also some specific platform things that you can do with Service Fabric. If I was starting brand new, I would probably go with just a standard microservices approach. Service Fabric does in fact run on, the cloud and is scalable and has a lot of the same features. But I would say it's recommended at this point. Not, I wouldn't say recommended, it's a bad word. I would say I would, if I was starting green, I would go with a microservices approach over Service Fabric. But that's just me. I would say look at what's there and see if it fits your needs. And Service Fabric is a scalable model. A lot of Azure runs on Service Fabric too.
Okay. Virax asks, can you talk about managing secrets across microservices and clusters?
Yeah, perfect. So secrets is a good thing. And there's things like I might have API keys that I'm using for external APIs. Kubernetes has a built-in way to do secrets. There's actually a whole resource on that within their YAML. So I can define secrets and do secret stores. It's built into Kubernetes. If you need an external storage for your secrets, you can use Azure Key Vault. And we have integrations with Azure Key Vault and AKS as well. So you can still manage them the same way. If you're going to manage across multiple clusters, I would say use Key Vault. Across the microservices themselves, you can just use the built-in kind of key stores that Kubernetes provides. And we've got some really good programming model as well for ASP.NET Core and accessing Kubernetes secrets. We have good integration there.
Yeah, we do actually. Can you kind of compare and talk to Docker Swarm and K8s?
Mm-hmm. Yeah, so Docker Swarm was a similar way to do deployments and management. They were somewhat of a competing platform early on. If I go back 3 or 4 years, the Docker tooling supports Docker Swarm as well in a way, but I would say that Kubernetes is kind of the winner. They're the de facto standard now for this type of architecture management. And deployment. In fact, the Docker tooling, Docker a couple of years ago started building in the Kubernetes support into their own tools above and beyond Swarm. So Swarm is kind of an early thing. There's another product out there called Mesosphere, which does a very similar thing. I believe Twitter created that, and it runs on Mesosphere. But Kubernetes now is kind of like, call it the winner. There was a 3-person race, and Kubernetes seems to be in the lead at this point.
And I have one last question for you before we kind of go to some resources. I've been saving this one, so Manish, thank you for your patience. What are the cons of microservices?
Oh, I saw this one coming. I had to take a sip.
The cons. Drink. Move forward.
Yeah, cons of microservices. First off, it can be a shiny penny, meaning that anytime something new comes out, you may have the need or want to go, oh, there's this Kubernetes thing. Let me go try it. Oh, there's this, XYZ SPA framework. Let me go do this. It's look at it and see if you need it, right? You can get into this fragmentation of how many thousands of pieces can I break my app up into when you might not need to, right? You just might not need all the scalability and everything that it does. It's good practice, but I've seen a picture of somebody putting like a box on the back of a 18-wheeler and said, I deployed my blog on Kubernetes, right? A blog does not need Kubernetes, right? A single page application doesn't need something like microservices and Kubernetes. So I think the desire to get there can be bad. You can see some of the challenges we even had going through this. There's things like these YAML deployment files. The tooling is getting better and better. But if I put a space in the wrong place in this YAML file, I could get stuck for a while. So I think those are some of the cons. It's the want versus the need. You really have to look at that. I would say that another con is there's a lot of opinions on how to do it as far as organizing your team versus your structure versus your DevOps process. As much as your application gets broken into pieces, all of the other parts of developing that application get broken into parts as well. So there has to be a common thread on what the goal is that people can lose sight of when it comes to building and deploying the application.
Yeah, so kind of a structured idea of their end-all goal.
Yeah, exactly.
So they all communicate.
Yeah.
Amazing. Well, we're about time. I want to make sure I share some resources here. Thank you so much, Shane. You're excellent, and this was all super, super useful.
My pleasure.
Thank you, secret producer behind the screen, as well as our moderators in the chat. Also, thank you everybody who joined our watch party. Yay! We'll have more information on future watch parties, as well as future events. This event happens every month, so stay tuned. Register on our website to get information about all of the events coming up next month. We have tons of resources that we launched this month, including my team member Nish's blog posts about microservices. We have architecture guides, we have new learn modules, we have updated documentation. There's a lot of stuff, and it's all totally available for you right there on the aka.ms/microservices_resources. Again, don't forget about the Learn Challenge if you have some time to complete those. All of the resources that we discussed in this session were actually on that resources link, so feel free to head on over there. If you have any questions for me or Shane going forward, please feel free to reach out to us on Twitter. We're available for you. If you had any issues running through the actual tutorial, we're happy to help step you through that as well. Thank you so much, everybody who joined. We really, really appreciate you taking this time to spend it with us. This was so exciting, and I can't wait to join you next month.
Thanks so much.
Thanks, Steve.